Howdy folks. Hopefully everything's set up here correctly today. Took a little bit longer to get the streaming setup running, but now that it is running, it should be good to go. All right, so the project we're working on today is going to be assembling the ButterStick, which is a board that I did a couple of streams on designing a little while back, but now we have the physical boards, so that's always a good thing. So we gotta assemble them up today. So we've got our assembly bill of materials here. So we'll just be working through this, solder paste on the circuit board, and then placing components. I can see if I have, add another scene here. There we go. There we go. So I've already gone through and sorted all my components. So they're in the tubs here, sorted by the order in the bill of materials. So it shouldn't take too long to find components. So it's just about pulling components out and placing them on the board. Hey Peter, yeah, well, I've tilted it so that it matches the board in my microscope, you know. Totally not trying to throw anybody's OCD off here. Looks like my chat overlay here is a little bit on the low side. Just push that up. There we go. Yeah, I think it's a relatively new feature. If I move back to the screen, in the settings, you've got board rotation. It's kind of handy if you wanted to put it upside down. I don't really know why you would use it at an angle, but if you're assembling something upside down or 90 degrees, it really makes sense. It could also be a newish feature. I don't know. This one says created using version 2.3. So, all right, this will be a bit of a fun board today. Here's the statistics. We've got 336 components to place. And that's for a single board. And I'm planning to do a panel of 2. I can announce it if you want, Peter. I don't know if, unless you beat me to it. Yep, there you go. You've just beat me to it now. Alright, so it took a little while to set up today because I had to add my other camera. So this is the microscope feed. Unfortunately, this camera here, I don't have enough lens adapters for my Sony cameras, and I only have Canon lenses. So I'm using the only Sony lens I have, which is a wide angle, and I can't get macro shots. So I'm going to have to put up with the ultra macro of the microscope, which this is as wide as it'll go, and then it can zoom all the way in. and then the ultra wide there. And I might tilt it down, the camera down a little bit while I do the solder paste. But that is the first step here. So just for anybody hopping in now, we're just assembling the new ButterStick board, which is a ECP5 development kit, which uses the Syzygy standard high-speed connectors. So it should be a fun board to assemble. We've also got two DDR3 footprints here, high-speed USB 2, and a gigabit Ethernet output. And one of the Syzygy connectors exposes all 8 lanes of the SerDes on the ECP5, so should, fingers crossed, everything works, but it should make for some interesting experiments once this board's up and running. Alright, so the first order of business is probably the solder paste. I'll move this camera a little bit so at least you can see the desk. It's not an ideal setup. Ideally I'd want a camera pointing up, but a wide shot of the desk, but I don't have the rigging required here to pull that off. So I'll pull out some blank spare circuit boards that I'll use for the stencil. So this is my big box of spare and miscellaneous circuit boards that I've accumulated over the years. We basically just use some of these to space around the circuit board here, and we'll put the stencil on top. It'll be nice and flat. Yeah, I thought the traces looked a little bit thin the first time I looked at the board, but I think it's partially due to the blue solder mask. It goes over the edge of the traces and it kind of distorts the light a little bit. I mean, this board was made by King Creddy, and they've e-tested it, you know, and it cost me a small fortune. So I assume it's going to work. And they sent me the TDR test samples. So all these traces here, the differential traces, they're all impedance controlled at 100 ohms. And they've sent me the test samples, so I can, if I had the equipment, I could validate that they are actually all 100 ohms. But I guess I'm trusting them now. Alright, so we'll do the back of the circuit board first. So it's double-sided load, so I'm going to have to reflow the back and then flip it over and reflow the front. I think I can probably switch to the other camera view. And then just bear with me here. Haven't really set up my streaming computer, so I'll just add the chat overlay here. Alright, so this is the stencil. So we've got one for the front and one for the back. I did them on separate ones because I don't really have much desk space here. So it would be, if you get both of them on the one stencil, it's going to be twice as large. So because we've got rails on the top and bottom, I think I'll only need to add support boards on the side here. So these are just some scrap circuit boards that are the same thickness. And my trusty blue painter's tape. So you can get proper stenciling jigs that hold the stencil in place, and it like levers up on top of the circuit board, and then there's kind of alignment pins that hold the board in place as well. I don't have any of that. I just do it the cheap way. I think to get a good quality version of that, they're about $1,000. So I've just gotten by with the old spare circuit board method here. And I'll just swing this out of the way. And I think I'll put one more board just up the top here. Something that I can pin it down to. And then I just kind of line it up by eye. I think there is about right. Now I've opted to get the fiducial marks etched through on the stencil, so I can use those to line up. Not necessarily the side with less components colors. I usually do the back side of the board and then the front side on the secondary flow, and that's just usually how I design the circuit boards. Typically you'd want to put you could do it either way. You can have high density components on both sides. A lot of my boards, I put all of the ICs on the top side, and then it's really just passives on the bottom. I find I'm not too constrained in board size. That makes a difference. But there are definitely circuit boards out there that the design requires you to put BGA components on both sides. And I have a few boards that I've done that on, but I prefer to avoid it if I can. It's just a personal preference. All right. So the downside of not having a jig to hold the stencil in is that you basically have to do this alignment every time. But that looks like it'll work there. So I can bring you around. Hi, Planet. Hope you're doing well over in Taiwan. It's a bit of basically in the midst of winter here in Australia, but it's Australian winter, so it's not actually that cold. We just like to complain. So if I pull up this, so here you can see the alignment. So basically got these fiducial marks etched through the board. So there's one and there's another. And so they're outside of the board, so you can use those to line up the stencil. And then once those fiducial marks are lined up, I can move this camera around, you'll see that it lines up over all the other parts. And I can lift it up after applying paste, and it should remain in alignment because of this tape at the top. All right, back here. All right, so next step, got my squeegee. I switched to one of these, essentially a bit of a proper squeegee. It's got quite a thick piece of stainless steel here, so you can really get a lot of force on the squeegee pull. I find that really helped compared to the, I think I might have one over here. Sorry, my lab's a bit of a mess right now. This is the old squeegee I was using, which is essentially like I think almost like quite a putty knife. I don't know the actual term for it, but it's used for plastering. So plasterboard repair, you can pick them up from hardware stores. So I just picked this up from the local Bunnings, whereas this one I just bought from AliExpress. But yeah, in terms of the blade on this is actually quite a lot thicker, and because it gives you a lot of leverage with this handle, you can really put a lot more force over the stencil. And it's even force across the whole width, which I find helps, but your mileage may vary. That's not to say I haven't got good results with that other squeegee, but right, so solder paste is cheap, so I tend to use more than I need, and because I have it in a syringe, I'm a little more confident that it's still good while it's in the syringe because it can't dry out as easily. But essentially, once it's outside of the syringe, it's scrap. It's got to be disposed of after you've used it. You can't put it back in the syringe. Whereas the other option is to use a tub of solder paste. Then potentially the tub can dry out a little bit easier, especially in summer here where it gets up to 40 degrees or so. I'm using GC10 solder paste, which is a SAC 305, so tin, silver, I guess, and then a little bit of copper, SAC, SNAG, CU, SAC, so lead-free solder paste. All my boards have been lead-free for quite a number of years now. I generally do 2 sweeps of solder paste like that, one to get it through the stencil, and then one at about 90 degrees to pull off all the excess. Just take a look here. Could be a little bit better, but I'll bring you in. I need a proper microscope light, like a ring for my microscope here. So most of the parts on this board are 0402s. And you can see that alignment's probably okay for the 0402s. I can swing it around here. Those DFNs look okay as well. They look passable. I mean, they'll reflow fine. This is probably the smallest part on this side of the board. And sorry for anybody that gets seasick here. Trying to do my best. That'll reflow okay. You can see once you zoom in on the microscope, the camera has a bit of a hard time with the exposure, but basically that will work. That'll work. It's gonna reflow fine. Actually, with a few of these components here, they're strap resistors. So you only need to fit one of them. So there's kind of like a pull up and a pull down resistor. And you can see on the stencil, I actually removed the aperture on one of the resistors on the do not populate. I don't know if I'll do that again. I probably should put solder paste on both of them, but you know, we'll see how it goes. It means that this stencil is a bit less universal if I find I have to switch those strap resistors. That's on the Gigabit Ethernet PHY. So they set options like the modes that it supports and the LED configuration and whatnot. Yeah, this microscope, the base of it is, it says even on the dial here, 0.7 to 4.5, and then it's 10 times on top of that from the eye pieces, but I don't know what the camera path sees. And then I've got a 0.5 times extender on the top, so that doubles the working distance but halves the magnification. Oh yeah, station 240. Specifically on these Ethernet PHYs, they actually reuse the I/O pins for these configuration options. So unfortunately, you can't just put a solder jumper because that'll knock out the I/O. All right, so I don't have much desk space here, so I'll have to clean this up. Yeah, so that solder paste application should be okay. I'll just move this back up. There we go. That application should be okay. So we can clean up this little bit of framework that we built here for applying the solder paste. And we can deposit the board back into our scrap board bucket. All right. We'll leave the solder paste on the squeegee for when we do the other side. Board. Just got a stick vise here that I'll use to clamp the board. I don't know if many of you saw on Twitter, but I had some interesting boards in this batch come back to me with like a jigsaw cutout between the two panels, which is interesting. I only noticed because so basically between the panels here, this little mouse bite tab, on some of the boards it's actually a jigsaw cutout. I can pull one out for you to show, because it's actually quite fascinating, but also a little bit, I don't know if scary is the right word, but maybe unnecessary. I think the idea is that it's less hassle for the assemblers. But you see, so this is one of the panels. About 3 of the panels I got were like this. If I get it in focus. So what they've done is they've got a special machine that actually routes out. So basically one of the boards failed on the panel. So say this board failed, but this one was good. They put the two panels in a machine, and they separate the boards with this kind of jigsaw cutout, and they can join two good boards together. And so you can see they've put a little bit of resin or glue at the side there. And yeah, so this is two separate boards in a panel that they've assembled together. And I think they do this so it's less work on the assembler, right? I mean, you just deal with all the boards the same way. You don't have to program in any X-out features. But yeah, so as I was saying, I noticed this because the first board that I pulled out of the batch snapped in two. So both panels separated really easily. And it was because it was one of these panels and the glue had failed. Yeah, so I don't know about alignment. That's where it's a little bit scary because and I'd never seen this before until Sean Cross showed me a photo of the FOMU panels, which apparently they did this on some of the FOMU boards. And if you know the FOMU, it's a little tiny board, but the boards are quite expensive. So obviously they didn't want to like scrap an entire panel. But the way that panel was organized, they had put, there was like rows, and they basically cut an entire row out and put a new row in from a good board with this kind of jigsaw pattern. And after assembly, all the boards in that row had failed because they weren't aligned perfectly. Especially on the FOMU, it's got these 0.4 millimeter chip scale package chips on it, and you've got to get alignment, spot on. And obviously, this method didn't support that. Yeah, I mean, I would assume that most, when you're working at that density, the pick and place machine would use fiducials on the board itself, which mine have, instead of fiducials on the panel, which is up here. But yeah, I'm not sure. Hey, Dr. Beeps. Right, so I'll put that panel back. I've basically been keeping, I've got 25 panels of this design. It's a bit of a trade-off between maximizing the NRE costs and then minimizing the costs of wasted boards if the design was bad. So I opted for 25, so that's 50 boards in total. And I'm going to be using the ones with that jigsaw connection. Probably be selling those as bare boards, possibly on like Tindy or something, just so if anybody wants to try building this themselves, they don't have to go to the pain of paying for assembly of a 8-layer filled via circuit board like this is. So yeah, my main thing with assembly is just that, especially for prototypes, I found that just the process of going through assembly with somebody like PCBWay or other contract manufacturers, it usually takes about an extra, like at minimum, you think it's going to take about an extra month, but it's usually about an extra 3 months before, like, you place your order, and then it's almost 3 months later you'll get your boards back, because they have a lead time on circuit boards, and then there's a lead time on them ordering components and then scheduling it into their pick and place assembly lines. And so personally, for prototypes, I really like assembling myself just for the speed. Once I've assembled it, I have a board and I can start actually playing around with it and writing code and doing testing. And yeah, JLC assembly looks good as well, but it's a little bit limiting in the part options they provide. I don't know if it's the same, but it's still, they at least last time I checked, they didn't have any connector options. Even though OCSC sell connectors, you can't put like a USB-C connector. They can't assemble a USB-C connector on your board for you. I don't know if they're doing that by choice because it's a bigger risk of failure or what, but yeah. And yeah, the main point behind the ButterStick design is for testing out high-speed prototypes of designs and whatnot, specifically with the ECP5 and the open source toolchain. And the rationale behind version 1 here is that it has the SerDes broken out. So with a reasonably inexpensive add-on board, we can prototype things like SDI video, PCI Express, SATA, possibly. I need to actually check this possible. Maybe 4K HDMI, because we have a 5 gigabit SerDes connector. And I say reasonably inexpensive. Whoop. I think I just lost the video here, and I think it's just because it's on battery power. I have a AC adapter on my Sony cameras, but only one AC adapter. So I was prepared for this, and I have spare batteries here. We'll see if it picks up automatically the camera feed. Looks like maybe not. Let me just, there we go. And we're back. Yep, so I've got, it's just the battery on the Sony camera I'm using lasts about half an hour. And we've been, about an hour, but it took a bit of time to set up the stream and ran out of power. I've got an AC adapter, but that's running my microscope camera. So I just put this one on charge so that we always have a spare battery ready to go. Oh, hey Sion. How are you today? Mouse bites. You seem to have... what do you mean way off? The drill hits are way off? So I didn't do the mouse bites on this board. They were done by the PCB house. So I just, they're experts in PCBs, so I figure they know best. But I did notice on the Orange Crab boards that they were leaving quite a burr. So these are the new, it's the prototype run of the new version of the Orange Crab. And I did the design for this myself. And so I put more holes, and they're actually inside the circuit board. So as a design feature, I've pulled back the copper layer that you can see and put the drill hits actually on the inside of the board outline, so that when you snap the boards off, I've got a couple here. Once you snap the boards off, even without any external filing or whatnot, you can see it's a little bit cleaner. A little bit. But I mean, that seems to work fine. It still gives enough strength inside the panels. Yeah, the main reason for plugged vias on this board, it's not essential for BGAs, not at all. You can do what's the term? Dog bone BGAs, where it's a via and a pad, and they're separated by a short trace, and so you offset all your vias at 45 degrees by half a pitch of the BGA. And that's an easy way to do it. But then you lose any routing or being able to place decoupling caps right behind. So I just went with plugged vias on this design because it's already a 8-layer circuit board, and the cost add-on for plugged vias wasn't too substantial, although I guess it all adds up in the end. But I wanted to try it out, so I just went for it with this design, and it gives me more freedom in the routing. You really get more space to route around, and being able to place components directly on the vias really helps with routing and whatnot. Yeah, so I think we could probably get started on the actual placement here instead of just chit-chatting. So I don't know what the best screen is to use here. Basically, I've got the HTML bill of materials plugin, interactive HTML bill of materials, which, if you don't know, it's a plugin for KiCad, and you basically just install it as a plugin, and then it adds a little toolbar icon in KiCad, and if you click it, you will generate this HTML file. You can see this is just a web page, and the HTML file contains a little board outline of your board, a list of all the components in the bill of materials, and you can go through them and see placement information. So I've been using this probably for the last year or two, quite a while now. Basically, as the first time I saw it, I kind of fell in love and started using it straight away. So, and I've sorted the components in order of placement. So we'll be doing the back of the board first. Let me just fix the rotation here. There we go. Fixed. And the back of the board's mostly passives, and then a couple of voltage regulators and miscellaneous stuff. We have 208 components on the back of the board, so it might take a little while to get through, but we'll just take it one component at a time. I think, so I've already pre-sorted the components here. So this is the first item on the list for us to place, and that should save us a bit of time sorting through a big pile of parts to find what we need. Oh, and I anticipate that placing components under a microscope might not be exciting for everybody. So, you don't have to stick around if you don't want to stay for the whole time. This will be recorded and put up on YouTube. The problem with streams, in my opinion, is that even if there's good information in them, they're just not very dense in information. So, but I mean, yeah, if you've got other stuff to do, that's fine. You can just leave. I'll probably still be streaming when you come back. This is going to take a little while. All right, so the first part on the list, which is almost always the same on any of my designs, decoupling capacitors, 0.1 microfarads, 49. So we're building up both boards on the panel. So I think I'll try. instead of counting out the parts, I'm just going to use a ruler. And we know that the pitch on 0402s is 2 millimeters. So I can basically just measure out how many capacitors I need here. 200 millimeters of length should give me 100. I cleared off my desk in order to appear tidier than I usually am, but that means that I've tidied up all my tools, so I might have to go hunting for tools every now and again, like I just needed my side cutters. So this is the first time I've assembled one of these boards, so I'm not 100% confident in where the parts go. So it's probably going to take me a little bit longer to assemble this because I'm going to have to be referring to the bill of materials here. And I have on occasion used a vacuum pickup tool for parts, but the problem I found with that, especially for smaller parts like 0402 and 0401s, is just that they don't sit very nicely on the tip of the vacuum tool. It's hard to get a nice pickup. So I'll be just emptied out the parts onto the bench here, and I'll just be moving them with the tweezers. I'll move you in a little bit. So you can maybe a little bit of a nicer view of the desk there. As I mentioned before, that camera doesn't have a zoom lens, so that's fixed focal length, and my tripod can't really be moved any further over the desk. Yes, I need to switch over. There we go. And then I will cut that down a little bit. All right, and all my scenes are perfectly aligned. There's no misalignment in any of those cameras. There's no overlap from the face cam over the microscope or the chat output. It's all perfect. All right. So this is basically where it gets a little bit boring and tedious. And I think I want to just take some isopropyl alcohol here and a little Kim wipe and just clean off the end of the tweezers. Often I found when parts stick to the tweezers, it's not usually magnetism, but these are specifically anti-magnetic, but it's usually just because there's some gunk on the end of your tweezers. And so if you clean them off, I found that helps to stop parts sticking. All right. Now, unfortunately, while I'm looking down the microscope, I can't see the chat window, so you can just talk amongst yourselves. Keep yourselves occupied. I'm sure Peter can answer any questions that you might have. just as well as I could. The one thing I found a little bit annoying about the stick vise is that it's got this kind of stick that pokes out the end. So sometimes maneuverability is a little bit of a pain. But that's also just my setup here. I need a proper ring light on the microscope. I think that would really help out with clearing out the desk. Right now I've just got a desk lamp that kind of gets in the way. But if I remove the desk lamp, the camera literally can't see anything. So when I was placing these parts in KiCad, it definitely looked like I had more space. They are a little bit on the dense side. This is one thing that you benefit from with via in pad, that you can place capacitors like this right over the top of the vias that run back to the BGA parts underneath. And you really reduce the inductance of the traces. But one problem with this is that it's a little bit hard to tell what orientation these capacitors should go in. So that's why the placement diagram here, which I've got pulled up on another screen, should really help. And I did mention earlier I've got orange crab boards to assemble as well, but I don't know if I'll do that after these boards or if I'll save that for another time. I don't know if my dexterity can hold up assembling two very dense boards back to back. And I never know how many, picking up capacitors here, never know how many decoupling caps to really add to a design. I generally try to have one per voltage rail pin, but even with all the ones that you see here, I've still not got one capacitor per voltage rail pin. I think there's like 50 VCC pins for the core voltage, the IO voltages, all that good stuff. The SerDes voltage, FPGAs have a lot of voltage rails. And of course you can't have a design without having at least one part that's at 45 degrees. Now if I was really trolly, I'd put, instead of putting it at 45, I'd put it at something a bit more obscure, like 31.6 or something. But I'm not that mean. $22.5, yeah. Exactly. Station 240 gets it. This board's actually a little bit larger than than most of the boards I've been working on recently. So it is a little bit more of a challenge to avoid resting part of my hand on the edge of the board. And there's actually not any components there, but you can. It doesn't take much to knock off some resistors if you're not careful. Yeah, Peter, it definitely feels like I'm shaking a little bit more than normal. It's probably just because I'm not used to having strangers on the internet staring at me under the microscope while I'm soldering. Not all of you are strangers, but there's probably still a few of you that I haven't met. Put this one. Yep. Don't worry, Drog. We're all strange in our own ways. It's not a curse. It's a blessing. I mean, take me for example. I could have paid for a machine to do this, but instead putting myself through the pain of placing over 600 components today. Yeah, I need to set up the music stream that Esden has in his stream, Peter. But uh, I'm just not really prepared. Whereas you know, he's done a few more streams than I have at this point. I am interested. Is that a is is that the music that you have playing the retro wave stuff? Is that royalty free or from some kind of radio channel? Uh, so I haven't been counting here. I think. There we go. I think that's all of the capacitors on this board. So now we do it again. Playlist on Spotify. Okay. Oh, and that's why you take it off on the YouTube VOD, because there's I guess a Spotify license isn't equivalent to being able to broadcast. Now I hope the microscope feed isn't too shaky. I've noticed that like if I move the desk too much, it starts to get a little bit seasick. And if I actually put my face kind of all the way up to the microscope, I can kind of knock it. So I'm trying to not do any of that, but it's just one of the cons to this microscope arm. I can move the microscope around, but it doesn't get, it's a little bit on the precarious side. There you go. I'm not, oh, it's because you use the term anal, as in anal retentive, but the moderator bot picked up an alternative definition of that word. I just got the, I think it's just the Twitch, automatic auto bot. What's on now? That the video looks like it could be a bit on the overexposed side. Just give me a second here. It's always a little bit hard with these Sony cameras. Often they don't output, like specifically the HDMI outputs designed for video professionals, shall I say, so more videographer types. And so there's a lot of settings in there to output in like a log format, so the image is less saturated, but there's more information in the image, but it doesn't look very good until you run it through some color correction, which makes it a bit difficult for somebody like me that just wants to plug it in and have it work. So the blue on the circuit board doesn't really match the blue that I'm seeing very well, but it's good enough. Yeah, see on the this specific microscope is a Meiji brand, Japanese brand, but and so I got the microscope secondhand for maybe about 30% of what it would have cost brand new, which was great. But I had to buy the camera tube and extension direct from the manufacturer or the distributor, which probably cost a little bit more than the Amscope microscope, and it's really just for like one lens and a piece of tubing. But I'm glad that the actual results work, because otherwise I would have returned it if it produced kind of crummy video. And then for the actual camera that's on top, the lens tubes adapt to a Canon EF mount, which is kind of a larger thread, but it's what I use on my my digital stills camera. But this camera gives garbage video. It's like 720p, pretty low bit rate. Basically, Canon didn't put much R&D effort into video recording on their DSLRs. I think they've gotten a little bit better with their new cameras, but then they're new cameras, so they're kind of expensive. So on this one, I've got a Sony A7S, the original A7S. So it's a full frame sensor, but it can't record 4K, but it can output 4K. And then I've got that piped into a cam link that's running on my desktop computer. So the full frame sensor means that it's great for low light, which is specifically, the microscope doesn't really give the camera very much light to work with. And so if I used my other camera, which is the one I'm using for the face cam here, that would be really grainy. So yeah, but I bought this Sony secondhand, and this specific one is pretty old now. I think it's, geez, maybe almost 7 years old. Because the A7S was one of the first A7 cameras to come out, and they're now up to the A7S III or the A7R4 maybe even. And now Sony has the A9. Anyway, picked it up secondhand, and it's almost useless for stills because the shutter is basically shot. I think it's almost got 200,000 shutter activations. So somebody must have been using it for some kind of mapping or automatic stills thing, like a macro slider or something. But you don't need the shutter for video, so it's still perfectly adequate for just as a HDMI camera with a really nice sensor in it. So I opted for that over the top of, so Meiji sell a USB camera for this microscope. Oh, if you didn't know, Meiji is a Japanese brand, so all their optics and stuff are top end, but you pay for it. And their USB webcam is like 720p, and I think they designed it back in the year 2000. USB 2. I think it's mostly for stills rather than video, but I think at the distributor the list price for that camera is at the order of like $3,000 or something, and you could get a lot better camera for that kind of dough. So and this second-hand camera here was nowhere near that, so almost a tenth of the cost. Yeah, this is these two little squares here are ground planes underneath QFN packages on the other side of the board. So instead of just having the little dimples where the vias come through, I thought I'd just put a little filled ground plane. I don't think it adds anything in terms of performance-wise. This is a multi-layer circuit board, and so there are already uninterrupted ground planes on other layers. But I think it looks a little bit nicer than having just the little dimples left by the plugged vias. right. Almost in the home run here. Home stretch. Yeah, one day I might fix my my pick and place machine, which is kind of hiding away in the background there, but today is not the day. I never get enough time to work on that. So, and even once I've put a bit of time into it, it's still not going to be very useful until I get some kind of feeder working. The main use case I can see for myself using it would be for LED panels. If I can have a feeder with some just a reel of LEDs, and if the machine is capable enough of picking up those LEDs and placing them on an array, that would be great, because I have lots of interesting LED projects that I'd like to work on, but designing custom LED panels is easy on the design front, but then quite painful on the assembly front. Yeah, so Sion, that's the, I think they call it, what do they call it? The abandon time on the paste. I think abandon time is from essentially what's on the squeegee. That's 24 hours. At least on the specs for this paste. And so I feel like it's pretty similar on the board. But I think they actually specify a lower time on the board, because once it's in a pad like this, it's probably easier for it to dry out. Yeah, so what they call the abandon time is 24 hours. I have actually started placing a board late at night and then not got it finished, and picked it up in the morning and not had a problem during reflow. So the paste is a little bit less tacky, but it's still got enough still got enough moisture in it that the flux is still able to activate. So I think that's all. I ran out of parts, but I pulled out potentially one extra part per board. Oh well, we'll see if we're missing a part once I've placed all of them. I'll be able to tell if I'm missing any decoupling caps. All right, so we'll move on to the next part here. Set this up as a divider. So we can hit N. Move on to the next part. I think there is a darken when placed. Okay, that only covers the list here. Okay, that's fine. So yeah, we've got more decoupling caps now. This time they are 0.47 microfarads. We need 22. It's going to be 44, 88. Is that right? Yeah. So we can measure out. We know that the pitch of these resistors is 2mm. So I'm just using a ruler, just a steel rule, to measure out components on the tape, because there's more components that I want to count. And so we can just snip them off here. All right, now we can move on to line number 2. These are mostly under the BGA package, as you can see in the diagram. So one thing that I think would be really cool is, and it's kind of on my project list, but it's one of those projects that I'll probably never actually get around to, is to set up a what do they call it? Well, it would just be a piece of glass here at 45 degrees under the microscope, and then like a black box and an LCD screen at the back. And the glass would act as a one-way mirror if you enclose the LCD screen. And essentially you could have an overlay visible in your microscope eyepieces. And so what you could do is have an overlay of this assembly screen shown in the microscope view. So you never have to, like I'm doing now, I don't have to lean back and look up at a screen. I can just be able to see, yeah, basically like a teleprompter. Essentially the same thing, like you would have a camera behind a screen that's angled, and the camera doesn't see the screen, but you see the screen. And you can do the same thing with a microscope. And I mean, I've got a 3D printer, so I'm pretty sure I could prototype up all the parts. And you just pick up you could prototype with a phone, like a phone screen, or you can pick up a little HDMI screen off eBay or AliExpress that would fit in the back. They're all the rage with these resin printers right now, aren't they? So you can get lots of high resolution, 5 to 6 inch screens that are set up for phones. But people have made little adapters that transfer HDMI to MIPI, I guess. Probably rearrange some of this screen here. Can make the chat a little larger for me, so I don't have to squint too much. Yeah, you could totally add a just a potentiometer, I guess, on your input here, and have it as a I don't know, a scroll wheel or some other kind of input on the computer side. I mean, you can do a lot with JavaScript these days, so I think even within the HTML BOM, you could probably script up to scale and pan around the preview. So I don't know if I need, I think I mentioned this before, I don't know if I need all of these decoupling capacitors, but I think it's worth putting them on these prototype boards. I basically followed all the recommendations about the SerDes connectors. So it's there's 5 gigabit SerDes on the ECP5 5G, which is the part I'm going to install on these boards. And so you can imagine that if you're trying to fling electrons at 5 billion times per second, 5 gigabits, you've got to be pretty careful with power supplies. And so there's a dedicated analog power supply on the transmit and receive side, which are these two parts down here. They're both LDOs, and they pull in the 2.5 volts, which is from a switch regulator, and we don't need any current at all on the 2.5 volt rail for the ECP5. But I put in a switching regulator so we can use an LDO off of that. That gives us a bit of a nicer, cleaner power supply. And they're rated up to a couple of amps, I think, maybe 2 amps each. But of course they're LDOs, so if you run them off the 5 volts and we're switching down to 1.2, you're throwing away like 80% of the power as heat. And I'm not sure what the actual power requirements are on this board yet. So basically everything is over specified. Like for all of the I/O voltages, I'm using DC to DC converters. Yeah, mostly the LDOs on the analog supply are mostly for filtering out, and so they're the high power supply rejection ratio, PSSR. I think that's the right term. And yeah, there are other ways to filter out power supplies, but I'm not a power supply expert, so I just stick to following some application notes and then put it on the board and hope that it works. All right, I think that's all the parts for that board. Now we'll go down to board number 2. Now I could have just been assembling a single board here, but I bought the stencil to go over two boards, and I want to start doing more assembly of panelized boards. So even though it's going to take a bit longer, we save on some time with the overhead of opening up the component bags and taking out individual components. And so I think in the end it's faster to build two boards at once instead of two single boards back to back. Yeah, much more time efficient. I guess the only downside is that if this board doesn't work, then and it's a design problem, then I have to rework two boards. But that's not actually that much of a problem. That really just gives me more Twitter content, right? Maybe I can put the BGA chip on 180 degrees on accident, so I have some more content to produce. Yeah, no, yeah, Peter, it is nice that, yeah, with two boards, and I have had this in the past, if one board fails, you can just load up the design on the second board, and then if it fails on the second board, or it works on the second board, you can track down what the issue is. It's potentially easier to track down. Or it's an assembly problem or a problem with yield instead of a design problem. Apologies if anything I do under the microscope here is off the camera view. I have quite a large view in the microscope than the camera can see. So right now I can see the top and bottom of the circuit board, whereas you really only see the inside here. And I think I can possibly move that around a little bit. I don't know if you're aware with the microscope camera, you get this haloing effect around the outside here, just with the way the lens works. And right now I can see the green, the green tip of the tweezers, whereas the camera can't see that. It has to come all the way in here. So I've just cropped it to kind of the middle here, so that we're getting rid of some of that haloing. Oh, hi Lethalbit. Don't worry about missing any of the stream. It's all going to be recorded if you wanted to catch up on highlights later on. I know time zones are definitely a thing, so right now it's about midday here. But of course when it's midday in Australia, it means that it's arse o'clock everywhere else. I mean, we could get around time zones by all of us just operating on UTC time, but I don't know about you, but I really don't want to be going to work at midnight. It's not really that great for productivity. So here's the last two. All right. Next item on the list. All right, so these are 1 microfarad caps now. Need 18, 26. So I've been ordering more and more passives now from LCSC because they're the same brand as what you get from the big boys in the distributor world, but they are much cheaper. But one disadvantage is I don't like how they package all of their stuff in these crinkly anti-static bags. Especially passive, so yeah, I much prefer the DigiKey bags, which are just static dissipative. So it's polypropylene material. I find it much easier to get the parts out of the bags, and they crinkle a lot less. But that's really just me being nitpicky, because it's still cheaper for me to buy from LCSC, so I'm still gonna probably keep doing it. I was surprised just how much cheaper for things like passives, even once you're at real quantities. So when you're ordering 8,000, 10,000 resistors on a reel, it can still be like half the cost from LCSC as compared to the more known distributors. So I really do like how LCSC's position themselves as being a bit more of a reliable, or a bit more of a big name behind buying parts from China. Because I probably wouldn't have been buying from Alibaba directly, but I'm happy to buy from LCSC because they give me a bit of a better website, and I can search the parts they have. Whereas on Alibaba, it's existed for from way before LCSC's been around. You'd been able to go to Alibaba and find a shop, a personal shopper in Shenzhen that can go around and order parts for you. But you've got to be emailing them your bill of materials, and they get back to you, and it feels it's just easier to have a whole online ordering system, and feels like I'm ordering from a distributor. Well, because I am, but yeah, little PCBs. I've found that their parametric search can be a bit hit and miss. Say for things like resistors. When I was looking for resistors for this project, you couldn't search by resistance. So I basically had to just pick one brand and then use look up their parts, the part number breakdown. And so, they tack on their resistance to the end, and I'd basically be creating part numbers myself, which actually I find works faster, faster than doing a web search, like a search and filtering through results. And I do like how their search bar auto-completes. So you can start typing a part number, and if it's in stock, or I don't know if it's in stock, if it's been searched before, it shows up in the autocomplete. And so for passives, I do that, and it shows you which resistances they offer as you're typing it in. But a lot of that on the search, like the back end, the database side, it's just a lot of tedious data entry. So I can understand why they don't have all the features yet of somebody like DigiKey. I mean, it means they can keep their prices lower, even if it's a bit more difficult to find parts. All right. So I think that's all of them there. On to the second board. Yeah, I really haven't been checking any of the stream quality or anything today, because as you can tell, I'm a pro streamer here, but it looks like it's working okay, which is surprising. And I do need to update my camera. Hang on. Just swap the battery out again. I mentioned this before, I've only got one AC adapter for my camera. So it's on the microscope camera, and I need to swap batteries on the other one occasionally. when I power it back up, it doesn't come up straight away. All right, there we go. Oh, hey Geordie, welcome to the stream. It's a bit of a, I don't know, bit of a relaxing, placement stream. I'd be doing this anyway, so I figured I'd, just broadcast it to the world. Yeah, I do wish I'd set up some music to be playing in the background, but yeah, I was not super prepared. So yeah, so as I mentioned before I realized the camera dropped out. Yeah, I haven't really been checking any of the stream quality, but I can see on OBS that I don't have any dropped frames, which is nice. Means that our NBN is actually working for once. Australian broadband's always a little bit interesting. Alright, so I just got to work out where these last two caps need to go, right here. So I've been measuring out the exact number of components I need to help with not missing any placements as I go. And so I've gone through all the parts, so there shouldn't be any that I'm missing. We'll see, as long as I don't flick them around. So we have finished that one. On to the next. 4.7. Not the first time streaming, but first time in a while. I did 2 streams back in April, actually designing the circuit board. And that was kind of just when some of our lockdown started here, and it's especially where I am, it's basically back to normal for now, but could change at any time, I guess. So I did 2 streams back in April, and then I really haven't done anything since. I lent my cam link to a friend, and so I didn't have that for a couple of months, so I couldn't even plug my cameras in. But no, I figured I'd dust off the old streaming PC. Had a little bit of trouble this morning getting everything set up because, I mean, it's probably what all streamers face, I guess. I think I have the similar problems to other streamers. My cam link wasn't running the right, didn't have any firmware on its flash chip because I had erased the flash chip to do some reverse engineering. So I had to reflash my cam link with its original firmware, which is set up by a bunch of Python scripts that Kate Temkin has written. And I think she's been refactoring some of those scripts, so it didn't work straight away. Had to go in, dig into the source code and adjust. Turns out it wasn't sending the right commands to erase the chip, so I was programming over the flash, and so it didn't work. And then once I got it loaded up with the correct flash, it was running. It would freeze after 20 seconds. And so I had to install the Elgato software and install the firmware update, which seems to have worked now. But I mean, that's just a classic problem, right? Most people erase the flash chip on their streaming hardware and then have to use open source reverse engineered tools to bring products back to life. Yeah, it does remind me at some point I do want to actually play around with porting some of the Tim video stack over to the Camlink as a target. It's hard to find motivation for that though, because it does work out of the box. So it's not like I'd be adding anything to the functionality, at least initially. But that's a project available for anybody that wants to partake. We've basically reverse engineered enough of the Camlink 4K so that we have a pin map of the ECP5 FPGA inside. And from the pin map, we have a Florent, the developer of Litex, has demonstrated his DDR3 controller running on the Camlink and booting Linux with a soft-core RISC-V processor. So we have a soft-core processor, we have DDR3 memory support. We'd need to write a driver for the HDMI sync chip that's on board, which unfortunately is under NDA, but there's been a couple of people that have found the datasheet and programming API for it. So that's actually not really a bottleneck anymore. Somebody would have to, sit down and actually write it. This is kind of unfortunate. I've got this capacitor not supposed to be there. And so I'll need to work out where that one goes. Yeah, I found the Camlink just kind of works out of the box, Peter, but their software doesn't really enable you to do anything else with it. I mean, it either works or it doesn't. And there's people online that complain that it doesn't work, and as there is, I mean, that's probably more a compatibility problem with specific cameras. HDMI can be a bit fiddly. But personally, I found it just kind of works. It shows up as a USB webcam, and then just whatever you plug into it becomes a webcam feed. Can be useful as a bit of a diagnostic tool, because I've been doing a lot of stuff with my own HDMI output on ECP5, and just kind of simple stuff, outputting 800 by 600 60 frames a second video. It works fine on a HDMI TV, but the Camlink wasn't syncing properly. So it was jumping around all over the place. And I think that could be a useful diagnostic, because I'm pretty sure once I get it working on the Camlink, it should also work on the TV again. But it's probably, I believe it's due to like an off by one issue. So instead of outputting 800 by 600, I'm actually outputting video as if it were a slightly larger, there's one extra pixel per line or something. And the TV doesn't mind because it's a TV. It's designed to accept basically anything. But I think the cam link, they've hard coded some of the values in for like 800 by 600 should be, X number of clocks per frame, this number of clocks per line, which is what I was following when I created the generator, but obviously something's still not quite right on the gateway side of things. Oop. Howdy, Nicole Man. Yes, these are all 0402s. I've got wanted to give myself a bit of a break on this design, so yep, the entire board doesn't go below 0402. Yep, so this kind of dense area here is right behind the ECP5. You can see the vias for it. Okay, so we have one left over. So either I didn't count correctly, or we still have one part to place. Oh, I spotted. I wish, especially if I can get one of the other projects that I'm thinking about, if I can get an overlay through the microscope camera, an overlay of the placement, it would be nice to modify the placement to actually step through each line item. So instead of showing instead of actually just highlighting each component like it does right now, if you could push a key on the keyboard and it could go through one by one, and that way you could actually place down, it would step through all the placements, so you wouldn't be left with one part and having to hunt for where to put it. All right, 10 nanofarads, next part. Oh, Jody, yeah, the board. I can fix that here. Hang on. There we go. It's fixed now, right? Yeah, Pyro. I like this tool. So it's, if you haven't seen it before, it's a plugin for KiCad. So it's called the Interactive HTML BOM plugin, and it just installs into KiCad, and then you push a button in your design and you generate this HTML file. So it's quite useful, and yeah, it kind of separates the design from the assembly stage. It's much easier to work through this, I found, than to have a KiCad design file open. 1224. All right. Oh, I didn't know that, Sion. Okay, so yeah, you can also use it in Eagle. I know it. Yeah, it does support a couple of different uh, different projects. I've only used it on KiCad. I don't think it mentions it here, but I know that they do have a Easy EDA and KiCad, and yeah, I guess somebody's made a derivative. They forked the project and created one that can work with Eagle as well. That's cool. Huh. I guess this one also is not supposed to be there. Yeah, I was wondering why I went through an extra capacitor on the 0.1 microfarads, and that must be it. Oh well, there's plenty of spares, so if I'm missing one, it probably won't make a difference. Huh. So I think I need one more. It's kind of strange. Ah. There it is. Ooh. Oh, okay, you can't use it inside of Eagle Xeon. Okay, so you just run it from the command line on the design file, I guess. Cool. Next part. 6.8. 6.8 picofarads. We've got 3 of these. That's one of the first parts that's gone flying today. Oh well, that's why we buy extras. Hopefully the rain isn't too distracting. It doesn't help that I've got a tin roof here over my lab. I can close the door in a minute. I might, once I place these, I might take a quick break to top up my coffee mug. And then we'll be right back to assembly. Ooh. All right, I think it's time for a quick break. I don't have anything set up on this stream as like a break screen, so I'm just gonna go top up my coffee cup, and you guys can do the same. And I'll be back in a couple minutes. All right, hope everybody's picked up a beverage of their choice. Yeah, so I've closed the door now, so hopefully the rain isn't as loud anymore. It's not too bad. It's probably gonna hang around for the rest of the day though. Yeah, so it is, the board here is Enig. It's probably a little bit hard to tell because of the lighting. Yeah, so it's all Enig. And that's basically the standard surface finish that you'd want for BGA packages. Helps with soldering, and then it's nice and flat. Actually, what I'll do is I'll twist this a little bit. Bit of a better camera view, so it's not so much streamception with this LCD screen here. In fact, I can move it a little bit over, so it's a bit of a better angle for me. Yeah, recently got these monitor arms that let me move the monitors around, and it's super handy. This one in particular is just the cable's a bit dodgy. But it's really handy with the microscope to be able to move the monitors in or out. And then cable might be on the way out. Yeah, really clears up the clutter on the desk as well, because the monitor arms come from the back of the desk and they kind of loop around. So yeah, I've got stuff on my desk all the way back instead of having the standard monitor stands that they came with, taking up all the real estate. You know, every inch of desk space is valuable for more junk to accumulate on. So, all right, next step. So we've just placed these. Nice. I'm getting into those 603 parts. We got 6 of these. One, two, three. So 6. Oh no! All right, so I did drop my finger on these pads here. I must have, because smudged now, but it'll be fine. Once you put it into reflow, you can basically get away with a lot. So as long as there's still enough paste on the pads, it should be fine. This one in particular is looking a little bit on the slim side. do a bit of paste repair here. Put a bit more on the output pin, and that's just another ground pin. That'll be fine. Oh, hey Kren, welcome to the stream. Yeah, just she'll be right. Kind of breeze through with the 0603 parts there, because once you've been placing 0402s, they feel huge. So we move on to the next ones. It's the I feel the same way about moving from 0201 up to 0402s. So on the orange crab boards, they make use of a lot of 0201. All the passives are 0201s. So when I'm placing those, you know, requires quite a lot of extra dexterity, I guess. And then as soon as you move to 0402, suddenly that burden's gone, so you suddenly just like much faster at placing them. Yeah, exactly, Kren. Once you've been placing 0201s, but I haven't done placement of 0201s for a couple of weeks now, so it's getting a bit rusty. Should have assembled the orange crab boards first as a bit of a warm up. You know, you need one complicated board layout to warm up for another. These are all the do not populates. You know, I wish it was all in my head, Theon. It'd be nice to be able to work quickly all the time. So, yeah, this is the list of parts here. We're up to these do not populate. So these are all the kind of the extra strap resistor positions. So like here, this pad of 9 pins is actually 3 resistors that can either be in, you know, one side or the other, and they determine the boot up state of the FPGA. And then there's quite a lot around the Ethernet PHY that controls some of its startup behavior. So we can skip over them because we don't need to worry about do not populates. And we're over all of the capacitors on the back side of the board. Grant, I had all all of the vias plugged. I don't think it makes much of a difference cost-wise to only do selective. I have seen it done on some designs where they only plug vias under the BGA. I suspect it's cheaper, but for prototype boards, I don't think it makes much of a difference. All right. Just to avoid having my hand straddling over the whole board here, I'll just flip it around, because all of these are all in the same place. These are all specified actually as 220 ohms, and I might need to change them because these are all current limit resistors for the LEDs, and I don't know what current I want to run them at. It's a little bit harder than just picking a value because the way the LEDs are arranged, they're multiplexed. So you do want to be running them a little bit brighter than you normally would because they're only going to be turned on for 1/7 of the time in the particular arrangement that's on this board. So I opted for 220 ohms, and we'll see if that works out. Xeon. I don't know about reduced or no angular ring. If you think about the geometry of vias, you do still want some what is it, annulus to the top of the via, because the copper has to make connection out, and if there's no copper on the top layer, you risk damaging the structure of the via because it has to be plated in, and if when they design the masks to etch away copper on the top layer, if the etchant gets into the via itself, it can it could etch out the internals of the via, which I guess is potentially, yeah. So you still need an annular ring. It can be reduced, but usually the companies that offer filled vias can do almost like quite small annular rings anyway. In fact, with Moltec, which is the company I do with the orange crab boards with, they say they can support 0.1 millimeter drills on 1.6 millimeter boards. And I think with the 0.1 millimeter drill, you can go down to 0.2 millimeter vias in terms of their overall size, which is kind of crazy. It's tiny. On this one, the space saving comes mostly from being able to place components directly on top of vias. So, for example, this capacitor here, it's basically placed right on top, so you can put things a bit more dense. On the orange crab specifically, we've got 0.15, so 150 micron drills, and 300 micron via diameter. But actually with the 300 micron diameter, they still do processing on their end and expand it up to, I think, 400, and then they cut back anything that any clearance issues, just because it makes it a bit more reliable in their process to do that. All right. Yeah, so I don't know if we actually need these two capacitors. So we have 3. So I put them all there, but we'll see if we end up with a pad without capacitors at the end, because we basically misplaced those earlier. 220. So those are all placed. 100K is next. I've been drinking, only the finest Coles has to offer. Moccona coffee. Shitty instant coffee. It's we have a proper coffee machine at work, and I don't know, I actually prefer the instant coffee just because I drink so much of it. So, but it means it's cheaper on my wallet. So yeah, I mean, I've drank from the espresso machines before as well. I find that if it froths the milk up too much, I get my stomach gets a bit upset. So I usually stick with flat whites anyway. But what do we need? 1728. Yeah, and I mentioned before, I'm a big fan of using a ruler to measure out and count components. It's much quicker and less error prone than individual counting. All right. Ooh, this is where things get a bit interesting, actually, because I need, this is 100K, and in particular, this board I'm assembling, I'm going to be putting the 5 gigabit ECP5 on this board, and the 5 gigabit needs a 1.2 volt core voltage instead of 1.1 volts. So that requires me on the schematic here. So the bomb was designed for 1.1 volts, but you can see right here, R74, this one, and R60 both need to be 118. So it'll make sense to me to fix those now rather than, I don't know where I put those parts. Got to be around here somewhere because I did see them when I was portioning this out. Aha. This looks like the ones. 118. Alright, so we have resistors on the bench here, so I need to not get these confused. So we'll just go in here, flip our board view so it matches what's on the bench. And we want to change R74 and R60. Yep, so these two resistors need to be 118. I don't have a good method for handling different variants of the bill of materials. I think a lot of the time that's handled outside of the EDA tool. Because it's only one component change. Well, in this case, so if this board's to support the 5 gigabit parts, there's it's not just one. There's yeah, these resistors have to change. The main FPGA changes, and there's some other resistors that change on the main power supply. And so I need to double check those as well. So this one, we'll do some live stuff right here. I don't have a note on the design for changing this to 1.2. I think these both have to be 1K, but I might be wrong. So I will check because so we'll put up the data sheet for the switching regulator. And what we want to do is work out what its reference voltage is. If its reference voltage is 0.6 volts, which it is, there we go, we're good. So we just, we want a 1.2 volt output, and we've got a reference of 0.6. So we can just change our feedback network to be the same resistors. So duplicate. And whoop. What? What are you doing, window manager? I just want to move the one. R65. Alright. Okay, so this is, we also have to work out what part this is. Also on the back of the board, up in that top corner. And instead of putting that as 84.5K, we want to output to 100K. All right. So that's this. I'll fix up the overlays in a moment here. That's this resistor here. There we go. So we can switch this screen back to our BOM and 100. All right, now back to the normal programming. What the smooth copper fills? Oh, you mean the fillets around the copper fills and stuff. Yeah, that's been a feature in 5, definitely. Stable has that. When you're in the dialog box for copper fills, you can add a chamfer or a fillet. Yeah, there we go. All right. Looks like all of it. 2 resistors left over, which is expected because the bill of material wants 4 in here. So that would have left us with 4, but we used an extra one up here on this feedback network. Ooh. All right. So a bit of a progress update here. We are 47% through all of our placements. That's for front and back. Just because of how many decoupling caps we have on the back of the board here. Yeah, it's a good question, Kren. The parts right now are just sorted by the bill of materials list. So on the bill of materials, there's the interactive bill of materials. I follow that list and just that's probably one of the follow that list as for the ordering, and I place all my parts just in a box. This box here. So they're all ordered in terms of using them, and I've just put the stencil in the middle here as a separator between what I've done and what I need to do. So these are all placed, and then these are to be placed. That way they're still in order for the next time I use them. Because I bought enough parts to build up 4 circuit boards initially. So I will, outside of the stream, be making up another 2 boards. So it's handy to keep the components in their sorted order, so that so I've right now used separate boxes. So this is the box for the top, and then the bottom. The problem is there's parts on the bottom that are also used on the top. So it could be a better divider, Peter, but the stencil was on the desk, ready to go. Right? You should know I'm not. I didn't really prepare too much for this. I did sort these parts last night, but that's about all. Ideally, you'd want some kind of spring-loaded box, right? So you have a like a lever and a spring load, so it holds all the parts up tight against the front. Because right now, as you're putting in single things, they could fall over, But that's just another project. I don't really want to be looking for yaks to shave. It was not a career aspiration to be a professional yak shaver. Yeah, that's a good plan station for 240. I generally buy parts. I have been buying parts on a per project basis, rather than having too much on like personal stock of parts. That's kind of changed a little bit now because, for example, all these parts from LCSC, you probably can't really see, but these are bags of 1,000. All of these resistors, I've just bought a bag of 1,000. 1,000 resistors is, I think, anywhere from 80 cents to like $1 from LCSC. So it makes sense just to order, 1,000, and then once I've assembled the 4 boards, I'll have all these spare parts that will then be moved into like stock parts essentially, and the next project I'll have to take them out of the stock. If only there was a piece of software that was easy to use that could manage all of my parts. I don't know if Sion is still around. Sion's been working on a website and a database for managing his component inventory. Looks like an interesting product, so have to give it a go at some point. The problem with component inventory is that it's a lot of upfront setup and time investment. So like you really want to get something that you're going to use properly. And one thing that I found, a lot of the component storage solutions. I mean, he's looked through all the available solutions. There's partsbox.io is a popular one. They're all online based, and I don't know. I don't. It means you got to pay a subscription, and like my parts aren't going anywhere, so I don't want to have a subscription to a service that tells me where my parts are. And then if I stop paying that subscription, all the data is useless. Like, I no longer have an inventory. I understand from the perspective of running it online as a web service, they have to charge a subscription. But it would be nice if there was a more standalone, locally hosted solution. All right, so 1K, we're done. 5K once. Yeah, I mean, you make a good point. If these services go out of business, you're like left out in the water. And I don't know what Sion's plan for that is, because his is also on his own web. He's paid for some web hosting or a VPS or something. Hi, Captain Morgan. How's it going? Welcome to the stream. Next, 51 ohms. These are the termination resistors on the DDR3 clocks. Yeah, Pyro, I've seen other storage solutions that highlight boxes that, where your parts are, they'll light up a square. Definitely feels like overkill to me. I definitely like it, that's a project in itself, and I don't think I make enough boards to warrant requiring a system that elaborate. Although the storage shelves, I guess, storage shelves that Chris Gamble showed us at M-Hub. So M-Hub was owned by Motorola, and then when they closed down operations, it became a bit of a co-working space for tech startups. They have a storage area out the back, and it's got these like a rotating carousel of shelves. So you push a button and the shelf, moves up and another shelf comes up from underneath, and it's like a big carousel inside. I can't remember how many shelves were in there, like 20 shelves or something. And so you can put storage of stuff on one shelf, and it doesn't actually, you don't have to lift or get anything. Everything's at like a table level. You just push the button and the shelf revolves around and gets the stuff you need. Of course, you need to know what shelf all your stuff is on. Otherwise, it takes a while to sort through it all. But it's a bit of an interesting concept. Makes use of the vertical space available without adding complexity for, requiring a forklift or a ladder to get to things that are up really high. Yeah, I'm not sure who's behind the initiative, but I think it did have a couple of people backing it to bring a bit more of tech space into Chicago. Tech and like startup kind of feeling. 1.5K. Mr. Frodo, once you've put board components on the board, you can't tell them apart. Basically, yeah, I can tell what they are because they have labels on the packaging. If they were just on the desk, you can pull out a multimeter and measure them, but they don't have any labeling on the actual chips anymore. Once you get below maybe 0603s, they get rid of the labeling. But if you buy 0603 or 0805s, they usually do have a silk screen showing the component value. Yeah, I think it would add cost if they were to color code the multi-layer ceramic capacitors. But it could be interesting to have a bit of a rainbow color scheme to a circuit board. But I think people would go for looks over function at that point. They'd want the neon pink capacitors, not really caring about what their value is. They want them for the color. All right. Well, we're slowly making it through the pile here. Got 23.7K. Now that I've got this upside down, I might as well spin it around. Just match what I'm seeing. It's not strictly required to have a microscope, especially for this size. Or 402, I could probably do without a microscope, but it's definitely easier if you have one, especially easier for inspection. So this is the widest the microscope goes, and then I can zoom all the way in. So you know, it's quite easy to see if something's not aligned at that point. But yeah, I mean, it's not necessarily compulsory. I've assembled boards for many years without a microscope, so you can definitely get started without one. And if you know you don't have a microscope, you can design your boards with larger components. It's always tough getting the corner of the cut tape. Alright, 4K7. Oh, that's cool, Mike. I've never used the OptiVisor before. Are they any good? They're the ones that it's like a whole visor that goes in front of, like over your head. I guess the advantage of that is that you see it's a bit easier with depth of field because it's your whole vision, or gives you a bit more viewing area. All right. Next. almost through all of the resistors, which is exciting. After the resistors, we get to place some ICs. We don't need this one. So that's the resistor we've just we replaced earlier, and it's switching the voltage from 1.1 volts to 1.2 because this ECP5 needs a 1.2 volt core voltage. So we don't need 84.5K, 47K. Just dropped the resistor through the through-hole component pad there. All right. Okay, that's all of the resistors. So, capacitors, resistors, now have some inductors. I'll just move that down. There you go. Yeah, I should have shipped you the boards, Michael, and then you can you could have assembled them. Actually, just received a board from Kurt. His Kimex board. To try a hand at assembling one of those. So that'll be exciting. I've got it arrived just before the stream today. So the little circuit board, you've probably seen it around on Twitter. Kimchi. Oh, okay. I didn't know what this. I don't know what any of these fancy symbols mean. Hey, Kurt. There we go. So yeah, no, it's, the boards look great. I didn't realize you were sending me all the parts as well, so it'll be fun to build up. Looks like a little bit of a finer pitch than some of the BGOs I'm working on today. Matches what the orange crab is, I think. Well, now I know for next time to call it the kimchi. I've only ever seen it written out with the, yeah, never heard it pronounced before. All right. Yeah, I've not used eMMC on any boards before, so it'd be interesting. I guess the only, it's basically like a similar to an SD card in a way, but I guess you need an interface on the board to program it initially, because there's no, you can't just plug it into a computer. So that's where it's a bit more complicated from a systems engineering point of view. All right, so these are some reverse polarity protection. No, it's an ideal diode controller, which is part of the reverse polarity protection on this board. I figured I should have it, so put that in. So basically this little chip, and then this is a N-channel MOSFET, and the chip performs like a boost internally and drives the MOSFET on and off depending on if the voltage is applied backwards. It's quite a neat little setup. 3 of these. And these are some DC to DC converters that I'm trying out. In a pretty tiny package, nonetheless. All right. Unfortunately, the depth of field gets a little bit slim when I've zoomed in like that. Sorry about the, if anybody's seasick, sorry about the waving around there. All right, next part. All right, here we have a voltage mux, which should select the either the higher voltage or prioritize the external voltage over USB, because I wanted a way to have the board powered from both potentially an external voltage source, because it is a dev board after all, but also support running off USB power. So I put this chip, which we need to work out what, I think it goes on this way, but it's got a bit of a funny footprint here. So just flicking parts all over the board here. So it's got this funny footprint. You can see this is the pin 1 indicator. So instead of being rounded, it's a square end. So that matches up with what I have on the board here. So if I can flip the part, there we go, you'll see that I have a square ended trace, and it should just sit on like that. That's one of the footprints on this board that I haven't used before, so I had to design up that footprint, and so it's good that the chip matches. All right. Next part, 2 LDOs. So this is some paste that I squashed earlier with my finger while reaching over the board, so it looks like it should be okay, but it's not a huge concern. I can rework that if it came to it. Alright, 30 megahertz oscillator. I wasn't sure if I needed 30 or 60 on this design. I ultimately went with 30 just because it was a bit more, there was a few more available. But ultimately this is generating, there's a PLL in the ECP5, and this is mostly used to generate the 60 megahertz needed for high-speed USB. We'll play the pickup game in order to try to flip the parts. They seem to be a bit top-heavy. Nope. I suspect that's a pin 1 indicator. Okay, I'll fix the webcam in a minute. Just a battery swap needed. As I mentioned before, the came straight back up. There you go. As I mentioned before, the my face webcam here is it's a Sony camera, and I only have one AC adapter, so I'm using the AC adapter on my microscope camera, not for that one. So that's still on battery. And I need to check. Yep, so that is pin 1. Once we flip it over, we'll be in the bottom left. All right, next part. We're getting close to being able to reflow here. It's telling me I've gotten 58% of the placements done. That's for top and bottom. So we only have another 10 or so parts to place on the bottom here. I have no idea what pin 1 is on this, so we need to flip it over. Yep, okay. So the indicator does actually line up. There we go. For these parts, often I'm pushing them down just so it gets a bit of, the paste is surrounding the component lead. It's potentially a bit of a problem more with passives like this than like ICs are a little bit heavier. But essentially if the part, so this is more likely to reflow correctly once they're pushed down. Especially for passives, it's quite easy to just have one side touching the solder paste. And if that's the case, when you go to reflow, you're more likely to get a tombstone where both sides might reflow at the same time, but if one isn't actually touching the chip, it could prop the chip up, and it only reflows on one side. So that's why I like to push chips down once I place them. We don't need to place the fiducials, so skip over that. Had a bit of a weird angle when I was placing these. They're all a little bit on the high side. All right. All right, so we only have one more part to place, and that is the SD card holder. This is a 8-layer circuit board. It's actually my first time making an 8-layer circuit board, so I was given the definitely cut down on the routing time considerably, having an extra layer to an extra 2 layers to put signals through. I feel like if you spent a bit more time on the layout, you could probably get this down to 6. I think 4 would be pushing it. But yeah, you could cost optimize and get the design down to a 6 layer board. One of the troubles is that it's the extra cost for layers isn't too expensive, and like to bring it down from 8 to 6 layers probably would take definitely a good 6 hours of my time to reroute the board down to that. So I just made the call to run it as an 8-layer board instead. So yeah, save a bit of time, but at a high cost. So. And also I wanted to try to make an 8-layer board. Sometimes we do things just for the fun of it. So that is all the parts. Oof. What are we now? 3 hours, 20 minutes. It's not too bad. So I think I'll do a quick once over of the board, and then we'll be ready to throw it into the reflow oven. It's interesting that these resistors are listed as do not populate. I think I put that in this design because I wanted to work out what values to use, or which strap options to use later on. So that's why all of these are unpopulated. Especially with the these strap options, they they're just options for the Ethernet PHY on startup, and so you can easily actually set all of those options once the device is started up. So it's not actually too bad. Yeah, the designs are up on GitHub. I'll throw up a link. Hang on. Give me a second here. Yeah, basically it's just a resistor on a data line up to ground or the I/O voltage. Yep, so that's the link to the design files if you want to take a look. I mean, I'm not sure how helpful a design review will be at this point, given that I've already got the boards produced. So if you find a bug, thanks, I guess. All right. I mean, this probably, most of this I think will reflow fine. It's always hard to tell. You don't want to, poke all the parts unnecessarily. But actually some of these are quite high. Specifically with these passive, these capacitors here, they weigh almost nothing. So when the solder reflows, there could be enough surface tension to pull them away from the other solder pads. That's probably fine. Yeah, you need KiCad nightly. I've just been trying it out. There's no real reason why you couldn't do this design in in the stable version. I don't think I'm using any features that exist purely in KiCad nightly. All right, so we can, hang on a minute, I'm gonna check if, what this part does, if it's needed. Huh. Interesting. So I guess I do need to put I don't know where that one went, I guess. Oh, it's 4.7 microfarads. Yep, still going here. We've just finished placing all the parts on the bottom layer. So I'm just about to throw this into the reflow oven. There we go. will be where the other... There you go. Never said I was really good at... I don't know how Twitch works, Karen, to be honest. Let's see. I think there is a way that I can add moderators, but I don't know. It's all text-based commands, right? So I can just go mod Karen, maybe? We'll see if this works. All right, well, that's probably about as much as poking around with the design I'm going to do. So we have our death trap right here. Say death trap just because it's got still got some exposed mains wiring. At some point I'll fix, but for now it's just operated within the lab, so I figure it's safe enough for me. I'm going to twist this around a bit. How am I going to do this? So I'll probably move this camera down in front of the reflow oven for you, because watching reflow is always fun. We can put this in this way. That should work. And then we need a light. All right, so move some cameras around here. So just bear with me. Even this one. Bit of tripod rearrangement here. Until I'm a pro streamer. And we need to move this camera. So unfortunately I only have one lens adapter for my macro camera, which is currently being used on the microscope. So I'll just switch some of these bits around. I know this is great visuals for you guys. And guys now have a macro view of the reflow oven. So I gotta get another light in here. And then we'll turn the oven on and you can watch the solder melt. A little bit precarious here. I'm not sure how. I don't know how much depth of field you guys need. We really don't have that much right here. We can probably push the ISO. Give myself a bit more space, move the light in. I didn't really plan how I was going to do this, so it's surprising that it's even working so well. So this is a Sony a6300 with a Canon EF 100mm macro lens. What do you guys think? Something kind of close like that, which shows the SD card, or focus more in the back, like a bit of a wider shot like that? In the back? Yeah, I think that kind of looks nice. Hang on. I'll move the light around a bit more. Just make sure the oven's not going to burn through any power cables here. So that would be a bit too much excitement, I think. What do you think? One other thing is that the oven's kind of loud sometimes. So I will probably dull the microphone a little bit. Basically there's a fan in the top of the oven that rattles sometimes. So just a bit of a fair warning now. And I need a extension cord. Alright. Actually, now we've got a bit more light, I should be able to, there you go, give you guys a bit more of a high depth of field there. And I'll So while that's running, I'm just gonna go to the bathroom and top up my coffee, and yeah, I'll be back in a couple minutes when it's ready to reflow. So it's just warming up right now. Probably takes about 5 minutes to do a reflow cycle. So yeah, just stand by. Yeah, looks like we're at about 180, 190 degrees. If I was a bit more organized, I'd have another camera showing you the temperature, or an overlaid thermocouple. like most ovens, the temperature that the thermocouple reads is a little bit different from the temperature that is actually present on the components and around the components. So we're at 210 right now, but likely we won't start actually melting until the reading gets to about 235. That's what the PID controller is set to as like a max temp. Usually once it hits 235, I just leave it running for another 30 seconds and then turn it off. So I don't actually have a proper controller here. It's really just a basic PID controller controlling the oven. So we should start to see reflow happening pretty shortly, maybe in the next 60 seconds or so. On the PID controller we're at 227. Again, from my experience, I usually start to see the solder actually melting when that reading is at 235. Alright, we're seeing some melting around the SD card there. It's probably gonna flow back through the components, it looks like. One problem is I put the board quite close to the front window, and so it's getting a lot of reflected heat on the front side of the board, and so the reflow won't be as even as if I put it a little further back in the oven. Yep, and even all the way in the back there, you can see we're getting nice reflow. Should probably have checked the time. So now the board's basically reflowed all over. We're holding it here for about 30 seconds. So I've just turned off the heating elements to the oven, and there will be another 20 or 30 seconds before I open the front door of the oven to vent and cool down the board. So we'll go through the cool down cycle now. So I'm going to have to move the light away because it's interrupting the front door here. Have to move the camera momentarily. Just open the door fully. And there's the wonderful noise from the fan. Alright, so hopefully it seems to have worked okay. Just bring the gain back on the mic now. So the fan gets a bit loud. See some resin at the bottom of the oven now. So I think I'll rejig the cameras and put this under the microscope. So I'll just leave you with my screen here. That's good, Kurt. I would use, definitely need some instructions for the kimchi as well. It's IMX8 processor, right? I've never used one of those before. It's a bit of a beast. Ooh. So there we go. Ooh. So I need to set this the camera back up now, which is right here. We need some. This is why people have multiple cameras, but still I don't have enough to not require switching them. Alright. Cable. Yes, Conrad, welcome to the stream. Just put the boards through the reflow oven. You just missed it, but it will probably be on the VOD. There we go. So, all right. So they're still a little bit toasty. But that yep, that should have done the trick. And we didn't burn the house down or electrocute anybody, which is always good. Yeah, and it's I did call them the ButterSticks, but luckily they do not melt when you reflow them. Alright, so just a quick inspection here. Looks like everything's reflowed quite nicely. So even some of these packages that looked a little bit sus. Linux Conf, no, it's a it's their Linus Tech Tips shirt actually. Yeah, these look okay. Which one? Oh, it was this one, wasn't it? On the other board. Yeah, this was. So this is the solder paste that I had smudged with my finger around this part. It looks pretty good. Unfortunately, my microscope kind of leans a little bit forward, so we get a bit of a perspective shift. So it's not sitting level, it's kind of tilted a tad just due to the way this arm works. And so we can't, unfortunately, can't quite see this front edge of the board very easily. I can bring a bit more light around, but it definitely is looking good. Oh, got our first victim now. So we just need to throw this under the hot air once we've reflowed the other side. All of these look okay. And they're looking okay on my end. Yeah, I think that's a pretty good success right there. It's kind of strange. I think I must have knocked that one off at some point. That must have been from just putting it in the oven. I can't think of when else that would have happened. Nice, at least over a first pass I can't see any defects on this board. And then this one only has the one. It's only one tombstoned part here. Sorry, this one does have a missing component. So one missing component and then one tombstone part on the other board. Easy to fix. That'll just hot air up nicely once we're done. Yeah, so I think the next order of business is the second side. So I'm going to just go and top up my coffee cup here. You guys can do the same. I'll be back in a couple of minutes and we will add solder paste to the top layer and place the rest of these parts. We're at, where are we at? In terms of placement, we have placed 62% of the board. So we have a little bit to go. But on the top layer, at least, most of them are larger components. So should be able to get through this in, I don't know, another 2 hours probably. I'll definitely be sticking around until this will get there. Oh, here we go. There we go. Just scared you. Yeah, I think it moderates links and stuff. But now that I've streamed on Twitch for a few hours, it lets me assign moderators. Okay. All right, so I'll be back in a bit and we'll do the other side of this board when I get back. topped up with hot coffee. See there. Oprah of streamers. Yeah, you know, bees for you. Well, I feel like I can just let the moderators moderate themselves. Esden can pull down the ban hammer if one falls out of line, or Geordie, you know. Can't just have one moderator. All right. Okay, so we need to set up for solder paste on the top layer, and reconfigure this for showing the top of the board. So we've basically just gone through and done 208 parts in 36 groups on the back of the board, and on the front we've got 128. So it should go a little bit quicker, but also that's in 45 groups, so we have more bags to open but less parts to place. All right, I usually place in order of the bill of materials, as you can see on the list, but I will, so this is the bill of materials list, and I generally place based on that list, but for this board specifically, I'll be placing these BGA parts first. That way I can tilt them and see around around the BGA balls and make sure they're at least aligned correctly. So we'll set up a jig for stenciling. So now that we have components on the back of the board, we need to essentially create a dam of circuit boards that we will prop up the board with, so that we can put a flat stencil on top. And I've got my tub of old circuit boards. It's quite a lot of old circuit boards. These should be enough. Hey, Sylvan. Yeah, the potential for screw up count. That can be a subscription only feature, I think. So with these boards specifically, I think I can get away with just one layer of circuit boards underneath. The only part we need to clear majorly is the SD card. I think the SD card holder, I think, is the tallest part. And this board is skewed, so actually a lot of these are not particularly flat. I might need another layer actually. It's kind of hard to tell. It's good to make sure this step is done correctly, because it'll save you time later on. Like if you mess up the solder paste application, it just makes it more difficult later on. My trusty blue full tape. I can't do much about the camera view without switching it around too frequently. Unfortunately, I only have one lens adapter. So unfortunately, I only have a 15mm wide angle lens on that camera. I can maybe move it around a little bit. Oh, I guess while I'm doing this, I can switch it over to here. Too small, yeah. There we go. I can't do much about the wide angle though, but I can get rid of, yeah, there we go. So we have the other stencil. So this stencil here for the top layer, it's a 2-up stencil, so there's 2 copies of the design that match the 2 copies on the circuit boards here. And we can roughly align the stencil like that. I'll grab some tape. I'll swing this out of the way. Okay, it's looking good, feeling pretty good as well. So there's a bit of a gap between the stencil and the board naturally, because these are quite cheap stencils. They're just from JLC, so they always have a little bit of a bow to them compared to if you pay a bit extra and get a fancier stencil that they've removed the curvature for you. But the idea is we've got circuit boards on the outside, and the rails on the top and bottom of the panel will help so that we apply even pressure. And as we're pushing down on the stencil, it's going to be squishing the stencil with the circuit board, and then so there won't be room for the paste to squeeze out. So I just apply a little bit of fresh paste, and then I used the squeegee on the first side, and so there's still a bit of paste on that. So I'll grab a spare circuit board, and we'll just transplant the paste from the squeegee onto the circuit board. And that way we kind of have a dam of paste that we can squeegee across. Johnny Jacks, this is Loctite GC10. It comes in a big syringe, at least the one I bought. You can also get it in a tub. Here we go. So GC10 is the brand. Well, Loctite is the brand. GC10 is the name. Unfortunately, this is the minimum quantity you can buy. 500 grams or 600 grams is the amount they sell it in. So, yeah, I have paste for a while. Its recommended shelf life is 12 months, and I think I've probably been using mine a little bit longer than that. I usually keep that tube in a fridge. There we go. So I've been adapting the 2-stroke method, which I know that Esden doesn't like, but we can agree to disagree. I think that worked okay. There's a bit, that's weird. There's a little bit, I must not have got enough paste on the edge there. Alright, we'll try a bit of a dangerous strategy here. I like living a bit dangerously. So assuming everything lines up, we can squeegee again, but it is risky because it's easy to screw up. And yep, there's too much paste now. But we didn't have enough coverage over some of the pins, so we would have had to redo it anyway. So we basically just have to repaste this board, which involves taking off the bulk of the solder paste, with a squeegee stroke like that, and then cleaning off the board with isopropyl. So we have some just kind of standard 99% isopropyl alcohol. This doesn't usually get rid of all the paste. What happens is some of the solder balls end up lodged around the solder mask and pads. So you can kind of tell that it's been repasted. Functionally, it really doesn't make a difference. But yeah, that is a good observation there. Using filled vias means that you don't get any paste inside any vias. But that won't stop it falling in all the crevices in the circuit board here. So once I've gone over it with paper towel, it's just good a couple of passes here. Basically, we're just trying to dislodge any solder balls that are in there, and then just got a light wipe over with the a lint-free wipe, because often you can get some fibers from those other, normal paper towel. Yep, there we go. And because we got a bit of squeeze out on the back of the board, I'm just going to do the same thing on the stencil. So a bit of isopropyl, and this is basically just to dislodge any solder paste that has accumulated around the edge of the pads, and when we squeegee will basically lodge between the circuit board and the stencil. There's no need right now, because it's all fresh paste, there's no need to make sure that we've emptied all the apertures of solder paste, because as soon as we squeegee more paste through, it's just going to push that through, since it's all nice and fresh in there. So last time I think it was at the bottom here. When I got to the end, it lifted up the other. So I'll just grab some more circuit boards to fit underneath. That should work well. I think we're going to tape down just the top of the board here. There we go. That won't actually, it's not going to work. So I'm just adding a bit more tape to the bottom, just to help it stay in alignment here. All right. Okay, so we'll give this another go. It's serviceable. It's just at the end I overran a little bit. I'll bring you in with the microscope. So let's out of the way so it doesn't squish the screen when I pull this arm through. So yeah, the solder paste on the board looks good. Good alignment on the BGA package. A little bit dense just on the edge here. Yeah, I'm doing the top side now. See on. So I've propped the circuit board up on some old PCBs. Yeah, but I'll show you if I take this off. Falls apart a little bit at the bottom, but it's serviceable. Yeah, I expected this to probably take about maybe 4 hours if I wasn't streaming it. And we're at the 4-hour 20 mark while streaming, so it's not too bad. I'd expect about a 50% reduction in efficiency. So this is where it falls apart. This board looks fine on the BGAs. It's a little bit skewed, but it's still going to reflow okay. It's really just these last pads here. So I'll just clean these up manually. In fact, these will probably reflow fine. And even if they didn't, they're visible once the connectors are on. So I can, yeah, I'd be able to fix them reasonably easily, but I'll just go through and clean up some of this excess solder paste. It's easier to do it now than once the board is reflowed. So I'm just using an X-Acto knife or a craft knife. And then get rid of just the excess. I mean, it probably looks like I'm making it worse, and I probably am. I just leave it. There we go. All right, but that's really the only spot is just on this connector here, and that'll be easy to fix up. So I'll just gotta nip out for a bit, but I'll be back in about 2 or 3 minutes. All right. So, I guess we better get started. It's probably not the best solder paste application I've ever done. But again, it's going to be possible. And here you can see, because I had to repaste the board, you can see around basically anywhere there's a little opening around solder paste, you end up with, there we go, here's the microscope view. You end up with tiny balls of solder basically around every single opening, because it's pretty difficult to get rid of that with just a bit of isopropyl. So yeah, these connectors are pretty robust, especially on the outside here. It's going to be fine. And I might clean it up a little more. It's hard to know. Because I feel like the more you poke at it, the worse it gets. But I mean, if I can just get them so there's at least a solder mask down between everything, that's probably all I really need. All right. Yeah, these Conrad, these Samtec connectors aren't too bad. But it's definitely hard with hot air to only heat up the solder enough to melt without also heating up. Like it tends to be that plastics end up heating up more than the circuit board or the solder paste. There we go. That's probably as good as it's going to get. Okay. So we can yeah, these are, I've been doing lead-free for years now. I don't think I've had any lead on any of my designs in at least 5 years. Rework's, not impossible. It's just a bit more difficult. All right. So what we want is our memory chips and the ECP5. That's why they call them flip chips. They flip out of the packaging. Alright, so these are some ECP5, there we go, 5G 85Fs, and some 8 gigabit DDR3 memory. Whew. So these will be pretty loaded out once they're assembled. I'm going to find my larger tweezers. Should have put I generally have 2 sets of tweezers. This is the problem with cleaning up. One that opens up a little bit wider than the other. Here we go. Or no, this will work. So I don't have any vacuum pickup tools, so I'm just kind of expanding one of these sets of tweezers here so that it's wide enough to pick up the BGA part and place it down. And then you just kind of want to pick it up right in the center so that it's not going to tip, and place it on the board. That's really all there is to it. There's no dancing around too much. At some point you're going to have to place the chip. So I'll just load up these boards into the stick vise, which I really enjoy using for holding holding boards while doing assembly. So we've got do a bit of focusing here. And all there is to it is, without shaking too much, just place the chip on the board. Now I've actually found it's pretty, it's very lenient once you place the chip. You can actually push it around quite a lot without damaging the solder paste. I've definitely had chips where I placed them at least half a pitch off so the bowls fit next to the solder paste, and you can actually push the chip up on top of the solder paste without really damaging it. Of course, your results may vary. I think it depends on the paste you're using and how accurate your stenciling was. That's definitely been my experience. And then what we can do is, it's a little precarious with a chip this large, but we can basically look at the side here and see that we're pretty much spot on. We could probably push towards us on this one, maybe 100 micron, and then maybe down So I'll just do that now. Again, these are pretty pretty forgiving BGA packages here. I mean, you can see that, yeah, that's going to reflow correctly. We could probably push it towards us a little bit here. Sorry if it's a bit shaky, but once you get into these magnifications, it's a little bit hard to keep everything perfectly still. But you can see here the BGA bowls are on top of the solder paste, which is what we want. And so, I mean, that's going to reflow correctly. And it's a little bit hard to see, at least on the video camera, what's going on. Unfortunately, I can't get the angle correct with the stick vise is in the way. The little stick bit on the vise. Alright, so yeah, they're placed correctly. Next will be the RAM. Now, one problem with the RAM is that the footprint is a little bit of a different shape. Like the silk screen here is a bit of a different shape to the actual package. So you do have to, it's going to be a little bit off. That's just something I can verify in a minute that they're aligned correctly, but okay. So this one probably has to come back. There you go. So they're both okay. I can just give them a bit of a tap, just to settle the BGA bowls into the paste. And these ones look good too. Yeah, I've not really actually made it too far into this cup of coffee yet. But yeah, that's probably one of the harder parts to place. It's always a bit of a mix with coffee because I've kind of a little bit addicted at this point. So I get shakes without caffeine, and then if you get too much caffeine, you also get shakes. So you gotta ride the line a little bit there. So I think what these chips done, I'll move on to the passives. So I'll just go back to the bill of materials here. One tool that is quite useful, you can get manual pick and place machines. So it's essentially an XY table and you have an armrest. Yeah, Jody, manual pick and place. So you basically rest your wrist on a little platform that then sits on an XY table that you manually move around, but it supports your wrist. And usually there's like a button with a spring-loaded, a button or a lever with a spring-loaded pickup tool. And so you basically drag this across to your part, drop down the pickup tool, pick it up, and then usually there's a rotation aspect as well. Yeah, usually they're not cheap. The one I saw was from a company, what do they do? They do other prototyping stuff. LPKF, I think. I think it's a European company. And I think their product for manual pick and place was in the like $10,000 range. So it was more expensive than an entry-level pick and place. But our university had one, and it was a pretty nice machine to use. Like all the bearings need to be nice and smooth in order to place parts accurately, and everything has to be nice and rigid while still being easy to move around. You could open up, you can lay out ECP5 on 4-layer. It's not too bad. It's just you need more room to escape the BGA. You should check out Matt Venn's ECP5 board because it's that's on a 4-layer with JLC PCB, I think, and he's used the same package. So this same package here, and it's built out as a Raspberry Pi hat add-on. But it's designed as a bit of a showcase, development kit kind of reference design kind of thing. All right, so let's try to knock this over. And 20, 40. I need double that actually. I'm trying to measure out the number of resistors I need. But I need 19, which isn't as easy on my old brain. So, yep, 20 of those. Okay. I don't think I need to start a render competition with PCB Arts. They're doing good stuff. No need for a competition here. Okay. Now I need to remember how to place components again. Feels like it's been quite a while since doing that reflow and then switching back to solder paste. Let me get back in the flow here. Again, I like to place the all the small parts first, so that's why I'm going through the passives. That's just the order in which the bill of materials lists them as well. But I did the BGA parts first, just so I get a bit of clearance around them, and I can do a bit of inspection and alignment. But that's purely personal preference. There's no, I could have placed them last. But I mean, yeah, one of the things, if you screw up placement of those BGAs and you were to mess up all the paste, then you'd want to probably avoid having to rework the board. So you would need to start from scratch. And I don't think I've ever actually done that before. Like once components have been placed, I don't think I've ever scrapped a board and taken the components back off. It just seems like such a pain. So I try to do as much as I can to avoid ending up in that situation to begin with. Yep, these are all 0402 components. I'm definitely excited for this board once I brought it up to start actually using it, because it's been a bit of a process to finish the design on this board. So it'd be nice to get some LEDs blinking. Don't know if I'll do that on stream today after I finish this side. I guess I could. Yeah, I guess I'll try to see if I can get something blinking away. Oh, thanks for that. I'll swap the battery out. So it looks like the battery in this camera lasts about an hour before needing to be swapped out. And I think I put a fresh one in. Yep. So sometimes it comes back straight away, and sometimes it doesn't. just gotta flip the switch here. There we go. All right. Yeah, I'll probably place an order for another AC adapter at some point. The one I got for this camera is just something off eBay. It actually arrived broken. One of the solder points for the cable that runs into the battery had unsoldered itself. And funnily enough, what they do is it's just the circuit that would normally be inside the battery, the battery management stuff, the charge, under voltage protection and whatnot. They've got that circuit board because it has the connector at the top of the battery. So they've got that circuit board inside a different plastic enclosure, and they scrape off the back of the circuit board, and they've soldered some wires to it which run out to an AC adapter. And so that's why it arrived broken, was these wires are quite rigid. I think Sony sell an AC adapter themselves, but they charge 3 or 4 times what I bought this one for. Yeah, I don't think this power connector is going to actually short when I'm using it, but yeah, in the renderings, definitely the Ethernet port had a bit of a ground flag that poked out here. Seems like I really didn't take out enough capacitors here. It's kind of weird. Must have miscounted. So we need 6 more. I do kind of wish this board had had some solder, silkscreen with the same quality as Oshpark, because that way we could add some identifiers to these parts here to show what orientation they need to be in. So right now I'm relying on the assembly guide here. I'm pretty sure my design actually did have some silkscreen, just like these 0603s have a bit of silkscreen on each side, but it's just too small for them to handle on their printers, so it just ends up being removed. And the last one. All right, next part. So these are still parts that were on the top and bottom of the board. So I have to move through the box of parts that I used on the bottom. Ooh, 7. Okay, it's quite a lot. Ooh. Okay. There might be a way you could get the I-bomb to work with Altium. I don't know how that really stands on Altium's side of things though. Because essentially you would have to be a little bit reverse engineering their file format, which potentially is not allowed as part of their EULA. Potentially, I haven't read through the EULA, but it would make sense that that's something they could have in there, which would basically mean that it's illegal for you to add add-ons to the software that you're paying for. Again, I don't know if that's actually a clause in there, but it could be. Yeah, you might be able to use position files and Gerbers, and that would get around that, but okay. One. Okay. Whoops. Gotta try not to rest my finger on the circuit board. It kind of smears the paste. bit restless on the placements here. Too much coffee, not enough coffee. I think it's more that just after streaming for 5 hours, you're just generally feeling a little bit more tired than when you started. Maybe that's just me. 14. Okay, so there's quite a lot of these parts actually. Yeah, I do want to finish the board on stream though. I've got all day, so might as well get it done. One, 112. Yeah, I put those just around the edge because there are multiple ground planes on this board, so that just helps stitch those together around the edge. If you're doing just a 4-layer board, it's not really necessary if you've only got the one ground plane. So oh, so you're still around, Sion? How'd you get on yesterday with the electricians? Did they finish all the work they had to do? Do you now have your 10 gigabit connection running? Yeah, I'm not sure about the vias on the edge. It might help with shielding. I don't know if it makes much of a difference, especially for this design. I'm mostly using it for, yeah, just for connecting the ground planes at the edge of the board. I realize this camera is being a bit skewed this whole time. There we go. So now it's lining up with my my visual view. Yep. Good night, Jody. It's probably getting a bit late there on the west coast. You too, Peter. Alright. Just a sprinkling of capacitors around the board. And I think that's all for this one. Ed, no. 10 gigabit internet just in Australia? No way. Even our 1 gigabit connections aren't actually that. Don't actually provide 1 gigabit. Yeah, Nicolay. Yeah, the solder paste is a little bit tacky, so the parts do actually stick. You can see I can tip the board, and the parts are going to stay on the board here. Yeah, the solder paste has a bit of a flux in it, and so they are actually quite sticky, and these parts really don't weigh anything. So it's really no risk, especially for passives. I've actually dropped circuit boards after placing them, and when I pick them up, it's only like the big chips, like the BGA chips might fall off, but all the passives stay on the board. It's actually quite surprising how strong the surface tension is. Okay, next part, 10K resistor. Yeah, I'm actually kind of impressed with the broadband that I pay for. I'm just on the. I actually don't know what speed I'm on. I think I'm on the 100 megabits a second. Is that right? 100 mega. Yeah, megabit. just with NBN. But it seems pretty reliable where I am. So, I mean, I don't get those speeds. I usually get about half, 45 to 60. But that's plenty for me. And when you pay for the 100, it's basically unlimited at that point. So you don't need to worry about bandwidth caps. But it's been holding up all day with this stream, so whereas my old internet wouldn't have done that. Would have dropped in and out. Pretty unreliable. Still, I guess all of us Australians can dream of what the NBN could have been. So it was promised to us as fiber to the home for everybody. Huge infrastructure upgrade for the whole country. But that didn't happen. Okay. One more line item down. Six. Conrad, it's a Meiji microscope, and I have a camera adapter to a Canon EF mount, but then Canon don't make very many good quality video cameras. good quality DSLRs that capture video. So I'm using an adapter to Sony, the Sony E-mount, and then I've got an A7S on this right now. I was mentioning before, the A7S is secondhand. It's kind of finished its life as a stills camera because the shutter has done about 200,000 shutter activations. And I think that's a replacement part that you can get Sony to fix. But basically as a video camera, I don't need the shutter. So it works great as a 4K HDMI output video camera. It's got a full frame sensor, so it works really well on the microscope, which gives it, it does struggle a little bit for light on the microscope. Yeah, and then out of the camera, it's got to go through a cam link, just a cam link 4K to basically just show up as a USB 3 webcam. I mean, it does work well for streaming. I bought the pieces over about a year. I didn't just go out and buy all of it at once. I just kind of like accumulating gear, but I know that it's, you know, I feel like it's a bit of an investment more than anything. Photography is a bit more of a hobby to me than a job. And I'm always bargain hunting for picking up, you know, leading edge products from like 5 years ago, like this Sony camera. So Sony's now released 2 revisions to this camera, and so this one, you know, isn't really cutting edge anymore, but it's good enough for everything I want to do with it. Does the D800 not do video recording very well? I guess that's something they've added in the D850. Has a lot of video features. I don't think the 800 or 810 does. I mean, they're still amazing stills cameras. Oh yeah, it is. It is a big camera, especially if you don't need the, you don't need DSLR. Some of the mirrorless options are pretty good. Huh. That's a bit of a interesting trace right there. Just noticed. It's funny because this board should have been e-tested, so I've got a hair. I have to take some photos of that later. Send some inquiries to the Fab House. Oh well, can't stop assembling this board just for that. Yep, cut a strongly worded letter. That's exactly what I'll do. What's interesting, because I can see the marks on the board where they have e-tested. It's a little bit hard to tell. It might be that it's not shorted. It kind of looks shorted to me, but I have to probe it out later. It's interesting. So I mean, it's just a differential pair that runs up to this this connector. So all of these signals are just basically from the FPGA out to connectors, and so it's pretty easy for me to test. And I can test that that's if that's going to be a problem, and especially that connection there, I can rework that. It's just you cut the trace in a short jumper. But ideally, I wouldn't want to have to rework anything on this board if I didn't have to. Yes. And the problem is finding defects like that. It kind of makes you, I don't know, question the, any bug or issue that might be on this board from now on. I'll kind of like question if it was a manufacturing defect rather than, something that I did. It kind of just reduces confidence more than anything. Really, that's just a mindset change, but it can be a pretty big influence on thought process about debugging or whatnot. Yeah, maybe they just wanted to do the the TDR testing on this board. I wanted a sample with a short in it. Anyway, at least I now have two. I'll have two board samples to test with. It doesn't look like the defects on the other one. It kind of looks like the trace just peeled up before they put the solder mask on. So it could be they're just too thin. I don't know. I mean, I sent them the design files and they, they verified that it's all within their manufacturing tolerances. So I don't feel like I'm in the wrong, but... 20 ohms. The board is just skewed like that, just for aesthetics, really. I kind of just prefer it being a little bit askew. Yeah, Conrad, I like the pin 1 selected as well. It's handy when you've got a design with where the silk screen isn't very visible. It can help out a little bit with some of the alignment. Help out with making sure the boards the components are placed correctly. 84.5. All right. Whew. Only about half a dozen more resistors to go here. These are generally the more, it's the more tedious part of assembly. I find all the resistors for, voltage dividers and setting voltage output on LDOs and whatnot. Oh, hey Arturo. Welcome to the stream. Yes, it is indeed me. Yeah, congratulations on your new company. Bit official now, I guess. right. Yeah, we just had a bit of a casual stream here today. Just assembling up these prototypes. So I, figured I'd be doing it anyway. Might as well point some cameras and broadcast it out to the world. I would have done it anyway. Yeah, exactly. Although it has been a little bit slower. I feel like yeah, there's definitely a bit of a productivity boost when I don't have to look up and read the chat and make sure that my other camera doesn't run out of battery. Drag racing outside. Yeah, we have, I don't know, hooning around is a bit of pastime for the Aussie bogan. Live in a bit of a bogan neighborhood, to be honest, so we do get people hooning around. Yeah, there's usually not, people usually aren't driving too erratically later in the night here. It's not too bad. I mean, right now it's about 4 o'clock, 5 o'clock. So, maybe they're just racing to get home. So these LEDs have a polarity marker on them. Okay. And we need to work out what direction they go on, because this marker doesn't really tell me very much. Now, I can take Conrad's suggestion and turn on pin 1 highlighting, and then so I know these packages. This pad here is our positive pin. So I think it goes down like this. But I guess that makes sense. The dot would be on the bottom. Hang on, I have another board I can check. This is what I usually do. I just check another board. Yeah, so the dot is on the side with the large solder land, which might be a bit hard to see through the lens here, but essentially you have the dyes going down, and this one at the top is red dye. It's a bit hard to see on the camera there, but it's a darker LED dye. These are RGB LEDs. And the bond pad for that runs up and over to this bottom left side. So basically everything on the bottom left, it's the positive bond wire, that kind of rectangle you can see in the lens there. There's 3 bond wires that jump over. And so that large rectangle on the left, bottom left, lines up with our silkscreen dot. Just like that. Yeah, I don't know how best to deal with LEDs. We actually faced this with the orange crab. The first, they ran a few hundred boards and put the LEDs on the wrong way. But we actually specified them correctly, matching the data sheet in the design file, so they quickly fixed everything up. And actually didn't cause me any headaches. Oh, it's weird. These are all from the same reel, but you see some of them have different pin 1 indicators, which is kind of bizarre. I guess these are kind of cheap LEDs, so it could be that they're from different batches, but they're on the same reel, or they're from two different production lines, um, and they combine them after testing, and they reel them after testing as well. Or, maybe they don't do any testing at all. That could also be a possibility. Ooh, okay. So we are moving through this. What do we have left? It's saying I've placed 87% of the board. That's top and bottom. So we maybe have, I don't know, there's some duplicates here. But we probably have maybe, and some of these I've already placed. It's probably less than a dozen parts left. So, yeah, time to get keen. Will be, yeah, I've just put 7 on. There wasn't enough I/O pins to put 8 actually, unfortunately. But there are 7 RGB LEDs, so you can, and with 7 you can display any ASCII character. So there's a bit of a compromise there, but. But yeah, I definitely understand why development boards have LEDs in banks of 8. I understand the utility behind it. I don't quite like these molded packages for picking up with tweezers. It can be a bit tricky. And I'm not quite sure. I want to just verify this. Just to make sure that that little bump there is actually the pin 1 indicator. So that's on the top right. Yep. So before I dropped it, so now it's on the bottom left. But the top left, once I flip it, that's what I mean. The package has these chamfered edges, so it can be tricky to manipulate. All right, so there you see the pin 1 indicator on the top left. And when we rotate it, we have the little nub in the package does indicate pin 1. Because it can be a bit hard to tell. Sometimes they are just manufacturing marks. I saw the other day on Twitter somebody some of the STM parts have one that's just in a manufacturing dimple, and the other side is pin 1. Yeah, so this is a USB high-speed PHY. There you go. USB 334X, enhanced single supplier high-speed USB ULPI transceiver. And so this will let the ECP5 talk at 480 megabits per second. And Kate Temkin has written some gateware as part of the Luna project that runs on the ECP5 and uses one of these PHYs to talk to the computer. And I think that project's far enough along that there is some, at least a binding into EP-try, which is something Sean Cross worked on for the ICE40 FPGA, and a USB implementation just using I/O pins, but that's only capable of full speed USB, not high speed. So yeah, that'll be a fun part of this project, is getting the USB up and running, creating some example gateware that makes use of the high-speed USB, especially with this chip. It's quite a large chip, and you could do DFU updates quite a bit faster than the normal full-speed USB can allow. So it'll be cool to port the bootloader that's running on the Orange Crab over to this board, but to be able to run it at USB 2 high speeds. Yeah. Oh, hey, Derek. Yeah, so this board as well is a bit of a test bed. Ignore the solder paste there, but on this this syzygy connector breaks out the 5 gigabit SerDes of the ECP5. So we should be able to do some fun experiments with USB 3, which I think some people have started on, and I think you can get it to enumerate as a USB 3 device. I think that's kind of where people have got the transceivers to so far. The one issue is just there just needs to be more boards out there that support it, because to get that to work, you have to run it through a PCI Express to USB 3 adapter, which is kind of the opposite of what you'd normally expect. Oops, just dropped some bits of flash. Oh well, this is why we buy spare chips. There we go. Save that one for later. Yeah, Luna runs in Diamond, so I think oh, it's on top of nMygen, so you would have to write some nMygen wrappers for the Mac X02, but I think that would be possible. And it can output just as a raw Verilog module, and so it should be possible to get it running if you put in a bit of effort on the port. The effort's mostly on the toolchain side of things rather than the actual USB side of things. And it could be somebody's already set up a port of that. If you go looking, although I think Luna specifically is mostly targeting ECP5 platforms. Yeah, it's a pretty good turnout, Arturo. I don't know why 50 people have tuned in, but I'm glad you're all here. Feel free to drop in and out as you please, because it's going to be recorded. It's going to be up on YouTube. I don't think I've made any blundering mistakes yet, so there's no reason why I shouldn't put this on YouTube afterwards. I am recording a local copy, so I only made that mistake once. This isn't actually my first stream, Arturo. I did a couple back in April, but I forgot to record a local copy, and then Twitch gets rid of archives after like a month or something. Yeah, I mean, I'm not sure. I'm using a dedicated computer to stream. But so I have a computer with some HDMI capture inputs, and then I've got a laptop that's outputting the HTML bombs running on my laptop, and then just the two cameras. And that's got it's my desktop computer with a graphics card, which is doing all the encoding. So like my CPU right now on OBS is telling me 12%. So I think that helps with the streaming, compared to if you're loading down a computer with encoding as well as trying to do stuff on it. You can get a bit jittery sometimes. I've seen that on some streams recently, just with running Fusion 360. I think they pulled up the rendering tab, and you could tell that the encoding was suffering a little bit because it started to get a little bit jittery. I must have knocked this part. It's a little bit off skew. Just poke it back. Yeah, I just noticed it was off compared to the silk screen, this corner. And yeah, the the silkscreen registration is pretty good on this board. So yeah, I must have knocked it when I put, you know, this chip on or something. Everything's quite close. Okay, so they're, wait, are they all done? 5, 5. Okay, need 2 more of those. I did, I think I flicked one of these voltage regulators. I'm pretty sure I counted out 10. Oh well, I have some spares, so that's not a big deal. Yeah, the PCB jig, it's the stick vise. So it's basically just, yeah, just a metal rod, and then this one spring-loaded jaw, and then there's a jaw on the other side. And it's specifically got grooves in the jaws for clamping onto circuit board. So these edges actually have a wedge, you know, like a triangle wedge cut out. So it like securely locks the board in place. More than anything, I just find it adds a bit of weight to the board, which helps when you're moving it around and whatnot. Otherwise, this has kind of moved this around. I think I could turn off the pin 1. Yeah, I've ordered, once I used the stick vise for my home lab, I ordered 2 for work. One of them also has the Teflon jaw option, so by default they come with these ABS plastic on the jaws, but they have an option for Teflon, which means that they're heat resistant. So you can do reflow or rework under them without worrying about the jaws melting. Or, you know, you can be like Kurt and reflow your entire circuit board, put it in the oven with the stick vise, which I don't know if they recommend, but they said that it's okay. I think the main problem with that was that the label can melt, because the labels are just like a vinyl plastic. Alright, so I also don't know what orientation this is, so let's take a quick gander. Alright, so we want to spin it around. So it's like, whoop. Just dropping parts all over the place. Yeah, this is just an ESD protection chip that sits on the SD card pins. I don't know if it's necessary, but I've put it on anyway. All right, we've already done that one. So we have a 25 megahertz crystal that's used by the Ethernet PHY. The Ethernet PHY's got a PLL internally, so it generates its own frequencies used for Ethernet 10 megabit, 100 megabit, and gigabit. And it also outputs a reference clock to the FPGA. So we can use the frequency, we can use this as a clock input to the FPGA, which is kind of handy. Hello, BG7YLL. I do not know Chinese, so I cannot attempt to pronounce your Chinese name. Just buttons. We don't need to place the fiducials. 100 ohms. Ferrite bead. 3. This is a 8-layer circuit board. And incorrect, Arturo, there's only 0402 parts on this board. I just have reasonably high magnification. Yeah, the scale's hard until you, if I try to put my finger in here, everything looks tiny, right? It's an easy mistake to make. We're not going to solder the Ethernet connector yet. Doing that by hand. Some logos. All right, I think. I've got the ones that This was the first item on the list, but it's kind of a large capacitor, so I opted to put it on later. Potentially we could possibly be putting a larger voltage. I know that Peter was talking about this with the Glasgow. This is on a 5-volt rail, and this is a 6.3 volt rated capacitor. So potentially once you're into more scaled manufacturing, it's hard, like there's tolerance in that voltage range. So it could be that some of these, even though they're rated to 6.5 volts, they get a bit more marginal at 5 volts. Which I don't think would cause it to fail as a short circuit, but potentially could reduce its lifetime if you're running them kind of at their rated voltage. And Esna was saying that a good rule of thumb is just a two times multiplier on that, so you would put a 10 volt rated capacitor instead of on a 5 volt rail, basically. Hey Beeble. Yeah, hopefully the stream's not too long and tedious. We've been at it now for 6 hours. Whew, geez. But bring up a board like this does take a little while. And hi Hashad. So these scissor G connectors have some mounting pins that fit in the board, and they're actually quite interesting connectors. So this is the bottom of one of them. So they have this spline down the center, and these tabs are a ground plane basically. So it ensures good signal integrity, and that ground plane solders down the middle of the connector. So that makes it difficult to reflow, difficult to kind of repair if the reflow were to fail. But luckily I've got pretty good paste application on all of these connectors down the center at least. You can see on the other board I kind of smudged up the paste right at the end, so I was squeegeeing kind of down towards me, and this is like the last bit of paste that comes through the board, and it kind of squeezed out around there. But luckily it's visible. Once it reflows, I think it's going to look okay. And if it doesn't look okay, it's easy enough to fix with an iron. So that's the plan at least. You know, I can rework it if required. All right, getting there. Last one. Yeah. Derek, yeah, it's I kind of thought this would be a long-ish stream. I was probably planning on about 4 hours, but we're pretty much done now, actually, so I'm not too far off. That's only 50% error if we're at 6 hours right now. Yeah, I'm not sure what happened on Twitch's end when we did the reflow the other time for the first side. Yeah, the chat stopped updating and it said 0 viewers, but I don't have any dropped frames here. So that must have, I don't know. I'm not a very good streamer, so I can't, I don't know why or what happened. Just kind of dropped out, I guess. The pipes are a bit clogged. I think these are okay. We kind of checked them before, didn't we? So I need a USB connector. Now I often do paste in pad on the USB, but I forgot about it on this one because I have to change the footprint a little bit. So that just means that it'll reflow all the electrical connections, and before I plug it in, I will have to solder down the tabs. Because without the tabs soldered down, it's very weak mechanically. These are USB USB 2 Type-C connectors. And so they don't have any, they're not like the micro B connectors you get where you put some solder underneath the connector itself. They're really just the connections on the back and then the pins that poke through the board. It's possible to add paste now, but it's I can just solder them when it comes out of the oven. That's really not a big deal. The main point is just to, avoid plugging them in before those pins are soldered, because otherwise it's only these back pins that are actually supporting the whole connector. All right, so just give it a bit of a once over here. And I think it should be ready to go into the oven. Whew. Gotta stretch out after going through that many placements. So we've done those. Yep, that's everything. So you can see, there we go. We're at 100%. Although it actually hasn't counted one of them as being placed for some reason, but I don't know, still rounds to 100%. Oh, actually we didn't place the Ethernet connector, but we marked it as placed. Yeah, it must be, we never marked this. There we go. Done. So 100%. Okay. Yeah, so I need to move some cameras around again to put you in for the reflow oven. I need to work out, I think I can just place the board on the connector. No, I'll do it properly. I'll prop the board up so that none of the components on the back are touching anything when it goes to reflow. All right, so what do I want to do? I want to move some stuff around here. I'll switch to the wide camera. So we want to make up a use one of these. Make sure it's going to fit. Yeah, it'll do. I don't have very many circuit boards that are this long. I work on shorter things, but I do have one. So I'll basically what I'm planning on doing now is just adding some circuit boards to the side of this, so that we can prop up the board during reflow, so that the components on the underside don't have any physical contact. Because while while we're at reflow temperatures, we don't want any of the parts being pushed or anything. So somewhere around here I have some capped on tape. So we can't use masking tape because it'll smell pretty bad once we get up to 300 or 235 degrees. So we've got to use some capped on. All right, we'll take a bare board. Risk unnecessarily moving around the board with all the components. I'm just taking a bare board to space out where I'm going to need bits and pieces here. Yeah, I'm not sure why, who was behind the decision to put masking tape in those reflow ovens, but I guess it's somebody's master plan. All right, I can turn this off. It gets a bit glary in the camera, but it's helpful from a lighting point of view on the desk here. All right, so basically this is just I'll tape down the board, and it's really just to provide a bit of clearance under the board because there's components on the underside as well as on the top. So all right, so these are the circuit boards. We want to be kind of careful with them now, I guess. We don't want to accidentally drop them. Ordinarily, I probably wouldn't need to do this. I'm just taping them to the board here because I really don't want this to... so my oven has a couple of... It kind of vibrates quite a lot. I'll just gotta replace the battery in the camera again. That one's also dead. Here we go. So sometimes it comes back and sometimes it doesn't. I've got to just restart here. So I've modified the toaster oven with a quite a large fan in the top, if you could see. So basically I removed all the heating elements and I put a 2.4 kilowatt kind of conventional oven heater inside that also comes with a convection fan. Unfortunately, the frame of the toaster oven isn't designed to handle a convection fan. So what happens is that at some temperatures, the metal kind of warps and you get vibrations. And it kind of sounds a bit horrible as well. And I have had on one or two occasions circuit boards moving on the tray and like have fallen off, which is always fun. So I can take that one out. And I wonder what direction we should put this in. I think this way will work. Yeah, that should work. All right. So I'll pull the camera around and throw the macro lens on it so that you can see. I'm not really set up for this, but it does work. So this is just a light that I had on there before. Once we close down the aperture on the macro lens, it needs a lot of light. So I'll just switch over this camera quickly. So what I have to do is actually, I've only got one Canon adapter. And so I have to kind of disassemble my microscope camera here momentarily. So this is the camera, my Canon lens adapter, because I only have the Canon Canon macro here. So we'll just remove the lens and pop you guys in a macro camera there. I think it's also closed down the aperture as I've requested, so if we open it back up, yeah, there you go. So 100 millimeters gives you, it's pretty zoomed in. And I'll just rejig the tripod. I'm a pro streamer here, as you can tell. All right. So if we pull that back up, we can point the camera into the oven. And you get a pretty good view, I guess. I don't know what you guys' preferences are. I could actually put could almost put my ultra macro lens on the camera, but then I think the working distance gets a little too short. So I'll just do this for now. We can push it back to about there. And then once we close down the aperture, you get a pretty good view into the oven. I mean, that's probably about as good as I'm going to get with this pretty precarious setup, to be honest. All right, so I'm going to have to kind of dull the microphone here because, as I said, it's kind of loud when it starts up. But I'll come back, and I need to run to the bathroom as well. But I'll turn it on and let it start warming up, and I'll be back in about 2 or 3 minutes when it's more up to temperature. All right, so we're at about 200 degrees right now. So I don't have a temperature overlay yet, but yeah, it should be another minute before we hit reflow. We're at 210. Yeah, I mean, I have a temperature readout right here next to the oven. It's just that with the macro camera, it can't see both. Like, I can't zoom in on the boards and also be able to see the temperature readout. All right, you can see some of the heat now. Definitely makes it a bit wavy. All right, we're about to hit reflow temperatures. So like last time, we'll probably see the front of the board start reflowing before the back, just because it's so close to the front window of the reflow oven. So I suspect those buttons that you see there, the buttons in the bottom left corner look like they've reflowed. And it's probably going to sweep back towards the back of the board. Yeah, Mr. Who, it's a Canon, well, I'm shooting on a Sony A6300, but it's a Canon macro 100mm lens. Yeah, Hashad, I don't know, it could be that my bitrate might be set a little bit high. It looks like I'm streaming at about 6,000 kilobits a second. And I don't think Twitch transcodes that, so it might just be a little bit high for your internet. Alright, so now that we've seen it reflow, I've waited another 20 seconds and turned off the heating elements. And I'll wait another 20 seconds before opening the oven door. And you're going to have to move the light here to do that. So with the door now open, you can see it's quite a bit more wavy. We get these heat waves coming out of the oven. And this is the noise that I was telling you about. So I'll probably just move that down. Sorry about that. No, so my current oven doesn't follow a profile. I've just got a heat controller, so I can set it to heat up to a certain temperature and hold that temperature. So basically I've got it set to 235, and when it hits 235 I just, it basically starts reflowing at about then, and then I just wait 60 seconds before turning off the oven. No, there's no damage to plastic connectors in this oven. Specifically, connectors designed for reflow are okay. Most SMD connectors are designed for reflow profiles, which is okay. They don't use a plastic that's melts on the during reflow. But say like a 0.25mm header, you can ask Arturo, they do melt. Alright, so I just moved the camera out of the way here. And here you can see a bit of the setup that I've got. So basically I just run this little controller on the side. Hang on. Sorry about the flickering. It opens up the aperture all the way when I decrease it. So I've just got this PID controller, which is just off eBay. You just search PID controller. And then the oven here has a large 2.4 kilowatt heating element in the top with a convection fan. So you can see the fan spinning there. And once I unplug it, you'll be able to see the fan stop. Alright, so I can turn the volume back up now. All the way here. There we go. Yeah, well that was fun. So actually it's probably still a bit hot. I'll leave it in the oven now, and I'll move the camera back around to give you guys a view through the microscope. This and this, and we can switch back to this view. All right, so just gotta rearrange the tripod here. I need to be like Arturo and get another 2 cameras. Did you say you have 5 cameras running? Alright, just move that like that. And pop a lens on you. Alright. So that's more or less a good view there, maybe a little bit higher. Okay, so still probably very hot. So I'll just move my microscope light around. Oh, that was fun. Yeah, so the BGAs are always going to be lifted up because they sit on top of the bowls. So there's a couple of definitions here. You can get BGA parts are bowl grid array. So they have basically solder balls under the chip that sit between the chip and the circuit board. And then there's a type of package called LGA, which is land grid array. And LGA parts, they are flat on the bottom, and then you have solder paste and then the circuit board. And so they sit flat on the circuit board once they're soldered. A little bit warm, but not it's not hot anymore. All right, so that's the yeah. So this is what I was saying with the little frame that I built here. Is basically just to lift the circuit boards up because I don't want them touching on the bottom side where they've got components while reflowing. So now I just have to free the boards from this harness. All right. Okay, so we've got yeah, the first 2 ButterSticks ever assembled. ButterSticks version 1. So these look good. It's going to be a bit hard to tell exactly how well the soldering's gone, but if there's any major problems, I can always just rework them. One thing that's interesting to me will be this connector. Ah, perfect. So if you remember how bad the solder paste was on the bottom of this connector, you can see it's cleaned up really nicely. I'll have to check check at a bit of a deeper angle here. I can't fit it under the microscope right now, but it definitely looks. It doesn't look like there's any shorts. Yeah, that's pretty cool. So I wonder if we should try. I could get a move my power supply over here, and then we can try to power one up and see if it powers up. And if it powers up without tripping a current limit, we can try programming one. I probably got maybe another 20 minutes that I can stream for. It's been quite a stream already, but it would be cool to test them before we end this. One thing that you can appreciate, I think, is nice, a nice crispy sound. Hang on, I'll find my pliers here. All right, here we go. Let me get some nice sounds for you. hopefully that was hopefully that came through. I'm not really much of an audio engineer, but yeah, so that's just the little tabs on the side. Oh, I have a camera here. So the little mouse bites on the side basically break off. So here's one, yeah. So on the middle of the boards, I've got to snap them off manually, so I just use some pliers. Yep, that's not going to work. Another way you can do this, which should work, is, if I can get them in frame, using some side cutters. You can just fit the tab in the side cutter and crunch. Cuts them straight off. And then we got another one here. So, crunch, crunch, crunch. All right, so yes, I got to heed the warning, and we will solder the USB pads. You didn't notice? Yeah, no, I'll solder the pads. I'll solder the pads. So one of these we'll just try it out. I'm gonna grab my soldering iron, which I put all the way back here. All right, pull this out. And there's the pads. So, I mean, you might be able to tell, but basically this is still pretty loose because it's really only held on by the back pins. Now I'm using one of these cheap irons here. It's a T12 clone, about $30 from AliExpress. And because I like my lungs, I'll just move my fume extractor over. There we go. So it might be a little bit loud because of the fume extractor, but grab some solder as well. Yeah, Eston. Peter, go to sleep. Oh man, I didn't anticipate how these have quite a large ground plane, actually. So I think they should solder okay, but yeah, there is quite a large ground plane. Yeah, 8 layers. It's pulling all the heat away. At some point I do have to buy a board preheater, but today is not the day. So it's pretty abysmal actually. That hasn't done anything. So definitely have to add a bit more heat, a bit more solder as well. So we should see it suck this solder ball down. Maybe kind of see it now. There we go. Let's see if that did any better. Yeah. I mean, it's got some of it. We'll just crank up the temp a bit. A little bit more. All right. Just clean these up. Yeah, I could do a bit more. I'll try to get a preheater for the next boards. Alright, so I need to grab my power supply now, which is on the other desk. So go here. And I'll switch the soldering iron. So we probably won't get time to power the board up on this stream. I'll have to update you guys on Twitter once I've done that. But we can try powering it up, see if we get any smoke. Could be a bit of excitement here. I'm just thinking that I'm going to have to solder in a debug header. So might not have time for that. Although maybe I can. We'll see. Alright. Contact. Alright, so I have a Frankenstein cable around here somewhere that I use for testing Type-C, USB Type-C. You can plug into the power supply. My lab is a bit of a mess right now, so I can't quite see where it's at. That's okay. We do have an external input power, which we could try as well. So that's that's our board here. I'd like to avoid just blindly plugging it into a computer if I can. Definitely want to have a bit of a current limit on the input power. That's kind of disappointing. I could have sworn it was just around here somewhere. Can't see where it would have been. Yeah, it looks like it's probably going to have to call it there today. If I can't find that power cable, there's probably no other way to test this. And I'm sure as soon as I end the stream, I'll find the cable. That's the most frustrating part about this. Yeah, oh guys, looks like that's probably gonna be the end of the stream today. But we did assemble both boards, and as soon as I've powered one up, I'll update the thread on Twitter that I've got for this project. So just a quick plug. You can find the design files for this board on GitHub, and I've got an ongoing thread about the design in general when I started picking it back up, which was kind of a little bit a while ago, maybe 3 months ago or so. I picked up the design and finished it off, and I'll just pull up the link to that thread, and then I can let you guys go here. There we go. Copy. There we go. So that's just a link to the Twitter thread, which I think is a link on your chats. So that's where I'll be posting updates about the project. Thanks for tuning in. Yeah, everybody had a good night. And Peter, get to bed. It's way too late over there. It's just I feel like going to bed, and geez, you've been up this whole time. All right, thanks for tuning in, guys, and see you around.